Hello students, welcome to the class. So today we will move on to the day 9 of this JEE 40 days crash course, and we will be covering an extension of our thermodynamics, which is thermochemistry. So please join the class. We will start our class in few minutes. Everyone, please join the class. We will begin in few minutes. So in the previous class, we talked about thermodynamics, the second and third law of thermodynamics, and the first law of thermodynamics is already discussed. So we are done with the thermodynamics part, and today we will deal with extension of this thermodynamics chapter, which is thermochemistry in the chemical reactions. This is an important topic and an easy one to solve if you are getting the concept behind it and the definitions. So in this lecture, you will mainly face definitions regarding various type of enthalpy change for various reactions. So those definitions are kind of important to solve the numericals. If I talk about the previous class, we talked about the second law and the third law of thermodynamics. The second law of thermodynamics was related to inotropy, right? So we talked about inotropy there and said that the total inotropy change must be equals to positive, or it should be equals to 0. Then and then only your reaction will be spontaneous in nature. So this del S total is the sum of enthalpy change of system plus sum of enthalpy change of the surrounding, right? Then it was difficult to calculate it for the surrounding, so we moved on to a new function, thermodynamic function, which is Gibbs free energy, and we said that for a reaction to be spontaneous, your change in Gibbs free energy should be negative, right? And to justify that, we have a formula. So that is delta G is equals to delta H minus T delta S. So this was the main point of your yesterday's class. Now, this is our disclaimer. So first of all, let me introduce you with thermochemical standard state. So thermochemistry is a branch of chemistry that deals with energy exchange that occurs between a system and its surrounding. Now, system plus surrounding, as you know it, it gives you the total universe. So this is your thermochemistry, which is basically related to the energy exchange. Now in this case, you have to remember that the energy exchange is related to chemical changes and physical changes, and it is not related to pressure volume work. So in thermodynamics, you will see two types of work or two types of changes in state occurs. So first is simply pressure volume work, where you apply pressure or you change the volume. So that is one case, and that is totally dealt in your thermodynamics. And the second case, which is your reaction part. So whether you are seeing a chemical reaction or you are seeing a transition, so that thing is dealt with your thermochemistry. Next, if I talk about any chemical reaction, so two things are possible. First is it is resulting in the evolution of heat, and the second thing is absorption of heat, right? So whenever a chemical change take place or there is a change in state of matter during processes like vaporization, fusion, phase transition, then you will see that there is evolution of heat or there is a absorption of heat. So the table we are talking about, which is your Gibbs free energy table and the spontaneity case. So that is simply logical. You can just uh, uh, analyze that and logically. It's very simple to do. You just have to take the equation delta G is equals to delta H minus T delta S and look that what delta H and delta S value will give what temperature for a spontaneous process. So something logical is there. You can just try to analyze that same. It is not there to mug it up. Okay, you don't have to worry about learning that thing. It is very much logical and very much easy to understand. The simple point is that you have to do two things. You have to take equation delta G is equals to delta H minus T delta S, and by looking at a given value of delta H and delta S, you have to decide that what temperature should be taken to keep the delta G value as negative. Now, if you talk about the heat change accompanying the chemical reaction or a physical change, so that is being measured using calorimeter. So someone is asking about calorimeter in the yesterday's class. So I have put up a slide here for discussing that same part. We will discuss that thing in the last part of the theory. Lastly, if there is a release of heat during a reaction, then we call that reaction as exothermic. Or if there is intake of heat during a reaction, then we call it as endothermic reaction. Okay, so these are some introductory part for the thermochemistry. Now we can have some examples of this exothermic reaction where heat is transferred to the surrounding. Here we are seeing a reaction between aluminium and oxygen to give the oxide of aluminium, and in that process 1676 kilojoule of energy is released. To indicate that heat is lost by the system, we will put a negative sign against delta H. So this is an example of exothermic reaction. We can also have endothermic reaction where heat is transferred from the surrounding, and in that case the system is gaining the heat, so delta H will be in positive. So here is the reaction for the same, N2 plus O2 giving us 2NO, and in this process 90.4 kilojoule of energy is being absorbed by the system. Now moving on to the thermochemical standard state. So a thermochemical standard state of a system is its most stable state under 1 atm pressure and 298 Kelvin, and to represent them we use the superscript O or not. Now here is the important point. Different substances have different stable state at your standard state. For example, if I take the case of oxygen atom, so it is most stable in the O2 form if you are taking it at 1 atm pressure and 298 Kelvin. Similarly, if you are taking carbon, then the most stable form of that carbon is in the solid form, which is for graphite. Okay, so there are multiple forms of carbon which is possible. We have carbon in the form of diamond, we have carbon in the form of your say fullerene, but the most stable form is your graphite. Yes, if you haven't watched previous lecture, no worries, just try to be with us. I will try to explain the maximum out of this 40 days crash course. Okay, so you don't have to worry about it. Now, the purest form of liquids and solids, most stable states are considered with 1 bar pressure condition and 298 Kelvin temperature. So what is being said here is related to the stable state. We will talk about this in the enthalpy of formation, right? So every atom that you see has a stable state. Like oxygen's stable state is O2. Similarly, carbon's stable state is carbon in the graphite form rather than in the diamond or fullerene form. Similarly, nitrogen's stable form is N2. Okay. Now, if I talk for a gas, then the standard state is considered at 1 atm pressure. Similarly, if I talk about a solution, then the standard state of the solution is referred when that solution is having a concentration of 1 molar. Got it? So these are some conditions for different kind of systems for standard state. For liquid and solid, your pressure should be 1 bar and your temperature should be 298 Kelvin. For a gas, the standard state is at 1 atm pressure, or if there is a mixture of gas, then its partial pressure must be 1 atm each. Similarly, if you are talking about the solution, then the standard form is referred for the solutions having a concentration of 1 molar, means whose molarity is 1m. Now we will move to a very important part, which is enthalpy of reaction. This was a theoretical part which was kind of important for understanding the chapter, but you are facing difficulty in understanding that, then also no problem. From here on, the most important part of the thermochemistry starts. So first one is enthalpy of reaction. It's very simple to understand. Whenever you do a reaction, then the heat exchange that occur for that reaction at constant pressure. So that heat exchange is called as heat or enthalpy of reaction. Now both cases are possible. Heat can be absorbed or heat can be evolved. Next, this whole thing is indicated by a thermochemical equation and denoted by delta RH naught. For example, if you are seeing here a combustion of methane to give us carbon dioxide and water, then this is your complete equation along with the states of each and every species involved in it, as well as the enthalpy change related to that same reaction. So this whole thing that you are seeing, this thing is representing your thermochemical equation. You have to write the state, the physical state of each and every species, as well as the enthalpy change of each and every for the whole reaction. Got it? Any doubt in this? So this is your enthalpy of reaction, and it can be simply calculated by subtracting the enthalpies of product minus sum of enthalpies of reactant. Next, what we can say, that delta RH is equals to summation of enthalpy of product minus summation of enthalpies of reactants. If you want to write it further, we can write it in the form of enthalpy of formation also. Now this is the most important equation which is often used. So I am telling it from the start. During a reaction, whatever heat is exchanged at constant pressure, so that heat exchange is the value for enthalpy of reaction, and this whole situation is represented with a thermochemical equation where we write the whole balanced chemical equation with each species denoted with its physical state and the enthalpy change that has been occurred during that reaction. Now if you want to calculate the enthalpy change during the reaction and you are not knowing it experimentally, then you can calculate it from enthalpy of formation. So for every species there is an enthalpy of formation. Like if I calculate it for the given reaction, then there must be enthalpy of formation for methane, enthalpy of formation for ozone, and enthalpy of formation for carbon dioxide and water. Suppose if someone tells you that how do you find the enthalpy of reaction of this given reaction CH4 plus 2O2 CO2 plus 2H2O, it's very simple. You first of all add the enthalpy of formation of products, which is for CO2 and H2O. Then you subtract delta H formation of reactants, that is your methane and your oxygen. Okay. Now next, a very important point to remember here. So for the species that are present in their standard state, their enthalpy of formation is always 0. What did I say? That enthalpy of formation, standard enthalpy of formation for species present in their standard state is always 0. So in these 4 species that are given here, which is your methane, oxygen, CO2 and H2O, I said it earlier that oxygen is O2 is the standard state of oxygen atom. Therefore, the enthalpy of formation for this 2O2 will be taken as 0. Got it? Is it clear to you? Again, I am repeating my part. So first of all, I said that enthalpy of reaction can be calculated by subtracting the enthalpy of summation of enthalpy of reactants from summation of enthalpy of products. Now for this particular reaction, there will be a value for enthalpy of formation of methane, CO2 and H2O. But the value for enthalpy of formation of oxygen is taken as 0 because oxygen is present in the most standard and stable state. Got it? Similarly, if a reaction involves the Cl2, so Cl2 again is the standard state of chlorine. So in that case, the enthalpy of formation of Cl2 will be taken as 0. Now, as I said earlier, whenever you are trying to represent the standard state, you have to use naught or 0 against the symbol. So here the standard enthalpy of reaction can be represented as delta RH naught. Next, if the enthalpy of formation of products and reactants are equal, then delta H is equals to 0. Now there are some processes where there is no evolution of heat. We can take the example of mixing of ideal gas. So whenever you mix two ideal gases, there is no enthalpy change. Then after, if the product is having a higher enthalpy, then the reaction will be endothermic because the delta RH value will be positive in that case, and delta RH value is positive, that means the heat is taken by the system and it is an endothermic process. Similarly, if enthalpy of reactant is greater, then in that case the delta RH naught value will be negative and the reaction will be exothermic, means it will be releasing heat in that case. So I didn't get your question. Thermochemistry does not depend upon pressure, but there are the term constant pressure has been used. So can you clear it for me? Next. So this enthalpy of reaction has various types, okay, because there can be a variety of reactions. The enthalpy of reaction is a general term. So for every reaction we can use this enthalpy of reaction. But you know it very well that reactions can be of various type, like combustion, or it can be transition from one phase to another. Okay. So for different type of reactions, we have different type of enthalpy. Starting from standard enthalpy of formation. Now what is the meaning of this? Delta HF naught, we have seen the use of this delta HF naught in the calculation of enthalpy of reaction. We said that enthalpy of reaction for any reaction is calculated by subtracting reactants enthalpy formation minus products enthalpy formation. So Cp and Cv are not used for species such as solids and liquids. Okay, got it? Because pressure and volume have no effect on the solid and liquid. So that was the statement that I made. Now if I take for example this reaction, got it? So here this reaction is the standard enthalpy of reaction for methane. Why we are saying it? So according to its definition, standard enthalpy change is the formation of 1 mole of a compound from its element in their most stable state. Again I am repeating my part. So what is the standard enthalpy change? So standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable state is called as the standard enthalpy of formation. For example, if I consider methane here, so here we are forming 1 mole of methane as written in the definition, and we are forming it from the elements in their most stable state. I said it earlier that carbon's most stable state is in the graphite form and hydrogen's most stable state is the H2 form or the gaseous form. So this is the reaction, and the reaction enthalpy related to this reaction is also called as standard enthalpy of formation. Got it? So this is the point I am trying to make, that your standard enthalpy of reaction has various types, and this is the first type where your standard enthalpy of formation is named as standard enthalpy of formation. In this case we are forming 1 mole of a compound, as suppose we are forming here 1 mole of methane from its element, and those elements are in the most stable state, like carbon is in the graphite state and your hydrogen is in the molecular hydrogen gaseous form state. Got it? So this is your reaction, and the enthalpy of reaction related to it will be your standard enthalpy of formation for methane. Got it? Any doubt till this point? Okay. So now we shall move forward. As I said it earlier, for standard enthalpy of formation of an element at standard state must be taken as 0. So if I ask you what is the standard enthalpy of formation for carbon graphite, you will tell me that it is 0. Similarly, the standard enthalpy of formation for hydrogen molecule, again it is 0. For oxygen molecule, again it is 0. Similarly, for sodium in the solid form, it is 0. For aluminium in the solid form, it is taken as 0. Okay, but in the case of methane, since it is not in the most stable state, therefore it will have some value. Now, the standard enthalpy of a chemical reaction is given as I said in the previous part, that it is simply calculated for any reaction that delta RH naught is equals to standard enthalpy of formation of product minus standard enthalpy of formation of reactant. So from this formula, you can calculate the standard enthalpy of any reaction that you know. So here delta HF naught is the HF naught P is the standard enthalpy of formation of product and R is for the reactant. Moving on to the next type of standard enthalpy, which is the standard enthalpy of combustion. So this is your second type. In the first type, what we said that in standard enthalpy of reaction is known as standard enthalpy of formation when 1 mole of that compound is formed from its element in the most stable state. Next is for combustion reaction. It is represented by delta C H naught. So basically, whenever you see that there is a change in enthalpy for the combustion of 1 mole of a substance, then the enthalpy change related to that reaction is known as standard enthalpy of combustion. For example, if you take methane and 1 mole of methane and burn it in the presence of oxygen, it will give you carbon dioxide and water. Then in this case, the enthalpy of combustion is minus 192 kilocalorie per mole. So for whom we are defining enthalpy of combustion? For methane we are defining the enthalpy of standard enthalpy of combustion. And why this equation is perfect for it? Because here we are taking 1 mole of methane and we are doing a complete combustion of it. Next, here the delta H value is negative, but in some cases it can also be positive, means heat can be taken up for the whole process. For example, if I take the combustion of nitrogen, then in this case what will happen? Delta H will be positive. So can you say that this given reaction has a value or can be considered for a standard enthalpy of formation for NO? Again I am repeating my question. So can you say that the standard enthalpy of reaction for this N2 plus O2 giving us 2NO can be considered as standard enthalpy of formation for NO? Is it true? Is my statement correct? So we know it for sure that this equation is correct for the standard enthalpy of combustion for nitrogen. But can this equation be also considered for a standard enthalpy of formation of NO? Anyone? Can you say it? Is it correct? To consider this equation for a standard enthalpy of formation of NO, remember, for standard enthalpy of formation, you should form 1 mole of that substance. Then and then only it can be considered for the standard case. But is it forming 1 mole of NO? Anyone who can answer this? Again I am repeating my question. So can this equation be used for standard enthalpy of formation of NO? So I said it earlier, standard enthalpy of formation is considered for those equations which are forming 1 mole of that substance and the substance which is formed from its elements in the most stable state. No, this equation cannot be considered as standard enthalpy of formation from NO because there should be 1 mole. Very good, Varshakre, very good. Now, next, here we have another equation. Here we are forming OF2. So, can this equation be considered for enthalpy of formation of OF2? Again, I am repeating my question. Can this equation be considered for enthalpy of formation of OF2? Anyone who is willing to answer this? So, can this equation be considered for enthalpy of formation of OF2? Remember, you have to form 1 mole of OF2 and from the elements in their most stable state. So, is it correct to tell it as the standard enthalpy of formation of OF2? See, if you will not answer it, I will find it very difficult to teach you, right? So, at least answer it. Try to answer this. If you have a doubt regarding this, you can ask it surely, but at least try to answer this. So you have to consider two things here. First, your compound should be formed from elements in their most stable state. So what are the elements that are there in your O and F? So they are oxygen and fluorine. Okay, very good. Yes, this is your standard enthalpy of formation for OF2 because it is formed from oxygen and fluorine, and both oxygens and fluorine are in their most stable state, which is F2 and O2. Further, only 1 mole of OF2 is formed. So all the criteria are met, and hence we can call this equation to be considered for enthalpy of formation of OF2. Got it? Now moving on to the next, which is enthalpy of neutralization. Now from the terminology itself, you can consider that this is something which is related to acid base reaction, because in that case only we see the neutralization process. The thing which is only left is to define it. So basically, it is the heat liberated when 1 gram equivalent of an acid is completely neutralized by 1 gram equivalent of an base. Remember, delta NH value is constant for a strong acid and strong base. For example, if we take the constant value, it is delta NH is equals to minus 13.7 kilocalorie per mole or minus 57.27. Now, why we are saying that this value is constant? What is the reason behind it? Suppose we take a reaction here where we are taking a strong acid and a strong base, which is HCl and NaOH. Here, in this case, if you cancel the common ions, so H plus and Cl minus, this will break into H plus and Cl minus. Similarly, this will break into Na plus and OH minus, and this will break into Na plus Cl minus and H plus and this will be H plus and OH minus. If you this is not broken completely, so it will remain as H2O. So your Na plus and Cl minus will be cancelled out. Overall, this reaction is nothing but the combination of H plus and OH minus to form H2O. Again, I am repeating my part. So HCl can be broken down as H plus and HCl minus. Similarly, NaOH can be broken as Na plus and OH minus, whereas your NaCl can be broken as Na plus and Cl minus. But H2O will remain in their combined state. If you cancel the common ions, which are Na plus and Cl minus on both sides, you will get your final equation as H plus plus OH minus, giving you H2O. Overall, it is nothing but simply the combination of H plus and OH minus to give you H2O. And this thing is observed for every strong acid and strong base reaction. Take the example of KOH and HCl. There also the K plus ion and the Cl minus ion will be get cancelled out on both sides, and you will finally see that there is simply a reaction of H plus and OH minus to give you H2O. Got it? Therefore, we see a constant value for each and every reaction which involves the strong acid and strong base neutralization, and that value is fixed, which is equals to minus 57.3 kilojoule per mole. But this thing is not true for reaction involving weak acid or weak base or both. Why it is not true? Because some heat which is released during the neutralization is used by the weak acid or weak base for their ionization. Since weak acid and weak base are not that much good for the ionization, so they take up the energy during the neutralization for their ionization. As a result of it, the net energy release will be not in that much amount. Got it? So that energy that is released will be decreased. Got it? So this is the overall point. So whenever you take a strong acid and a strong base, always the neutralization process for 1 gram equivalent will have an enthalpy change of 57.3 kilojoule per mole with a negative sign. But if you take a weak acid or a weak base or both, then the heat released will be decreased by some amount, because some of the heat released will be used for the ionization of the weak acid or weak base, as they are not good at that. Okay? Easy to get? Now, the absolute value of neutralization of HF is more than 57.3. So this is the second exception. Why it is more than HF, more for HF? Because apart from your neutralization, there is a second process which is going on. What is that process? It is hydration of fluoride ion. So when you dissolve H plus and F minus, fluoride ion is hydrated in the water and large amount of heat is released. So apart from the energy release during combination of H plus and OH minus, you are also having the hydration of fluoride ion. So this is also having a value which is greater than the absolute value of enthalpy of neutralization in simple cases. So you can just go and watch the previous lecture also, and on our website we also have a live doubt clearing session. There is a link for it, and from there you can ask doubt related to same. So if you are not getting it, no worries, you can just go and watch the previous lecture, and also if you have a doubt you can ask it there from our live doubt session, which starts from 10 a.m. in the morning and ends at 6 p.m. in the evening. Now next we have enthalpy of atomization in the standard condition, represented as delta AH naught. So whenever you break 1 mole of bond completely to obtain atoms in the gaseous phase, then the enthalpy change related to that process is known as standard enthalpy of atomization. For example, if you take X2 as a diatomic molecule, then the enthalpy of atomization, the bond dissociation enthalpy, the bond enthalpy are same in their standard state. Next, we have lattice enthalpy. What is this lattice enthalpy? So this is the fifth type, where the enthalpy change is related to that process where 1 mole of ionic compound is dissociating into ions in the gaseous state. Suppose you are taking NaCl and you are breaking it down in such a way that it gives you Na plus in the gaseous state and Cl minus in the gaseous state. So the energy released during the breaking of this 1 mole of the ionic compound to give the ions in the gaseous state is known as lattice enthalpy, and it is represented as delta lattice H. Okay, so you can see that same reaction here, and for this process the heat which is released is 788 kilojoule per mole. Anyone who has a doubt till this point? So any doubt till this point? Okay, now we shall move forward. Next is standard enthalpy of hydration. So what is in standard enthalpy of hydration? Whenever you take an anhydrous thing, and that can be a salt of course, and you dissolve it in water, then what will happen? It will combine with a required number of moles of water to form a hydrated form, a specific hydrated form related to that species. So in that case, the heat which is released is your standard enthalpy of hydration. For example, if you take copper sulfate, so copper sulfate, it is when dissolved in water, it takes up 5 moles of water. Okay, so it can form CuSO4.5H2O, which is the specific hydrated form of anhydrous copper sulfate. So what we are taking? We are taking the anhydrous form of copper sulfate. We are dissolving it in water to give a specific hydrated form of copper sulfate having 5 moles of water along with it. And the enthalpy change during that process is minus 78.21 kilojoule per mole and is known as standard enthalpy of formation for copper sulfate. Now, during dissolution, physical state of the compound changes, while during hydration, there is no change in the physical state of the compound. So, this is the difference basically. So, it is not simply dissolution. If you take NaCl, suppose, and you dissolve it in water, it will dissociate to form Na plus and Cl minus. But if you are doing the same for copper sulfate, it will not dissociate. Rather than that, it will take up some water molecule to form a hydrated form. Got it? It is not changing its physical state, it is still in the state that it was taken. So in that case, we call it as hydration rather than dissolution or dissociation. Now moving on to the next, which is standard enthalpy of formation of solution. What is standard enthalpy of solution? So when we take 1 mole of substance and dissolve in a specified amount of solvent in the standard state, then the heat enthalpy change related to that process is known as standard enthalpy of solution. Now, how it can be calculated? It's very simple. So basically, it is delta H lattice minus delta H hydration, means the energy released during the breaking of a crystal minus the energy released for its hydration. So that will give you your standard enthalpy of solution. So basically, you are not keeping that value which is being used for hydrating the molecule. Got it? You are interested in only that thing which is related to breaking of the molecule. Got it? So basically, your lattice enthalpy of lattice includes both your solution as well as hydration. Now, integral heat of solution is the enthalpy change when you are dissolving 1 mole of solute. Okay, so when you are specifying the amount of solute to 1 mole, then in that case, your standard enthalpy of solution is named as integral heat of solution. Now, differential heat of solution is in that case where 1 mole of solute is dissolved in a large volume of solution, so that no enthalpy change occurs on further dilution. So this is known as differential. So when we are taking a definite amount of solvent and putting inside it, we are putting 1 mole of solute, we call it as integral heat of solution. And if you take a very vast or large amount of your solvent and in that you dissolve 1 mole of solute, so in that case we call it as differential heat of solution. Is this clear to you? Any doubt till this point? Anyone who has a doubt till this point? So you may ask your doubt without any hesitation. Okay, so we shall now move forward. So next is standard enthalpy of hydrogenation. It's very simple. So whenever you are taking 1 mole of unsaturated organic compound and you are completely hydrogenating it, then in that case, the enthalpy change is known as standard enthalpy of hydrogenation. Remember, I told it earlier. So, these are all the forms of standard enthalpy of reaction. What different kind of reactions? Here we are taking a hydrogenation reaction. We have seen enthalpy reaction, neutralization reaction, formation reaction. So, that depends upon the type of reaction you are taking. You will name it differently. Now, here we can take example of, suppose you are taking ethene and you are trying to hydrogenate it, then the enthalpy change during the hydrogenation of ethene to form ethane will be named as standard enthalpy of hydrogenation. Next is standard enthalpy of dilution, which is delta dilute H naught. So, when you take 1 mole of a substance and you try to dilute it in such a way that further dilution is not possible, okay, or there is no heat change on further dilution, then this enthalpy change during the whole process is known as standard enthalpy of dilution in the standard states. Next is standard enthalpy of fusion. So here are some simple terms. You will get it easily. So when you are melting 1 mole of a liquid solid substance in the standard state, you will call it as standard enthalpy of fusion, and it is opposite to that of solidification. Next we have for vaporization. So whenever we are converting 1 mole of a liquid into its vapor state, then enthalpy change related to that process is standard enthalpy of vaporization, and it is negative to that of standard enthalpy of condensation, because these are two opposite process. Then we have standard enthalpy of sublimation, where we are converting 1 mole of solid into its sublimes or gaseous state, and the enthalpy change related to that process is named as standard enthalpy of sublimation. So, during sublimation, two processes are occurring. First is you are fusing it, and second you are vaporizing it. So, you are doing two things here. You are converting a solid into liquid and liquid into vapor, and all in one step. So, if you want to calculate the standard enthalpy of sublimation, you can simply add the standard enthalpy of fusion and the standard enthalpy of vaporization. Now, next state is standard enthalpy of ionization, where we take 1 mole of covalent compound and on dissolution of water, it get splitted to give us ions in the solution in the standard state. Suppose we take 1 mole of acetic acid and dissolve it in water to give us 1 mole of acetate ion and 1 mole of H plus. So here we have to define or keep the amount of acetic acid fixed to 1 mole, and the heat released during its dissociation will be known as standard enthalpy of ionization. So this was all about the different types of standard enthalpy of reaction. I hope you got my point. So it is easy to get once you are knowing the actual process or the actual motive behind it. Okay, so all are pretty much same, but there are minute differences and they are important. The most important is the standard enthalpy of formation, and the standard enthalpy of combustion, and the standard enthalpy of neutralization. Then the next important parts are related to standard enthalpy of transitions. Got it? So this will be your important part in your all definitions. Now what is Hess's law of constant summation? It says that enthalpy change for a particular reaction is always constant, independent of the path that we have taken. Why? Because enthalpy change is a state function. Suppose you do a process by from going from A to B directly, and the enthalpy change during that process is delta H. The second way you do it is by going to a multi-step process. You go from A to C, C to D, and D to B, and for each step we have different enthalpy of formation as delta H1, delta H2, and delta H3. Then in that case, if you have to calculate the enthalpy change for going from A to B, you can directly calculate it from adding delta H1, delta H2, and delta H3. Although you don't know the delta H, you can calculate it from other part that you have taken. So basically what I am trying to tell it here is that you don't have to worry about the path that is being taken to for the conversion. For every conversion, the enthalpy change will be having the same value. Okay, it will be having the same value for every process, because the enthalpy change is a state function and not a path function. It depends on initial and final state. Now, next, a very important part, which is bond energy or bond enthalpy. Whenever you take a bond and you form it between two atoms in gaseous state to completely form a molecule, then the heat evolved is known as bond energy or bond formation energy. Next is bond dissociation energy. So first was formation and this one is dissociation. It is basically that amount of energy which is needed to break the bond of a particular type in one molecule of that given substance or compound. And the third thing is bond energy, and it is basically the average value of dissociation energy for the same type of bond present in 1 mole. Okay, so it is possible that you have to calculate the bond enthalpy for a certain type of bond, but there are multiple types of that same bond. In that case, you take an average value rather than taking a single value. Suppose you have to calculate the bond energy for the CH bond. So 4 CH bonds are possible in case of methane. In that case, you will take an average value rather than taking a single value. Okay. So we can also calculate the standard enthalpy of reaction using this bond energy. Now here, rather than subtracting reactants from product, we will subtract product from reactant. So we have now two formulas to calculate the standard enthalpy of reaction. First is from the standard enthalpy of formation, and the second one is from the bond energy, which is required to break the bond in the case of reactant and in the case of product. But here we take opposite case. We subtract product from reactant and not from reactant to product. You can see it here. So first is sum of bond energy of reactant minus sum of bond energy of products. Now, in the case of polyatomic molecule, as I said, you have to take the average bond energy rather than bond dissociation energies. For example, if we take methane, then the average bond energy for CH bond is bond dissociation energy of CH4 divided by 4. So it can have negative value, and if it is negative, then the bond formation occurs and it releases energy. Whereas if bond formation occurs and bond value is positive, that means bond dissociation is occurring. So these are the two things you should remember. So always there in bond formation, there is a negative value because heat is released. And in the case of bond dissociation, the heat is always absorbed. Okay, so what is integral heat and differential heat of formation? I am telling it again. So in integral heat of solution, what do? Is you take 1 mole of solute, got it? And you try to dissolve it in a specific amount of solution. So that is known as integral heat of solution. Now, next we have calorimetry. So someone asked about calorimetry. It is basically an experimental measurement for calculating the heat change of a reaction. Okay, and it is calculated by using the tool known as calorimeter. So it is a laboratory experiment in which heat changes in physical and chemical processes are measured inside an insulated container. Got it? How do we calculate it? It's very simple. You will simply use the formula mCs delta T, where C is the heat capacity of the whole substance and Cs is the specific heat capacity. Then delta T is the temperature change and m is the mass of the substance in grams. Now, for endothermic process, this Q will be positive, and for exothermic change, the Q will be negative. So this is the formula that you already know. But how to use it in the question? Let's see. So for heat of conversion, it is measured by placing a known mass of a compound at constant volume bomb calorimeter. So bomb calorimeter is always referred for constant volume case. Now this thing is filled with oxygen at about 30 atm pressure. On ignition, what will happen? There will be evolution of heat, and that can be calculated by measuring the amount of temperature rise in the water. So all of this thing is done in a water bath. So combustion is done inside a container. This container is surrounded by all sides from water. So whatever heat is released is taken up by the water. So we can write it as heat lost by the sample is equals to heat gained by the water. Then the Q combustion will be Q water plus Q bomb. So there may be some heat which can be dissipated or not absorbed by the water. Then in that case we investigate the temperature change of the whole calorimeter. Therefore the total heat will be Q water plus Q bomb. Now if you know the specific heat capacity of water, you can place it here. It is sea water multiplied by the mass of water. Similarly for bomb calorimeter you can do the same. Now next we have Q combustion. If you calculate this Q combustion in the bomb calorimeter where we have kept the volume constant, then your Q combustion will be equals to delta U combustion, which is internal energy change. Therefore delta combustion of H is equals to delta U plus delta NGRT. So from this you can calculate delta H as well finally. Lastly, we will talk about calorific value. So what is calorific value for a fuel or food? It is the amount of heat in calories or joules when complete combustion of 1 gram of a fuel or the food is taking place. So suppose delta Hc is the heat of combustion, and when we divide it by the mass of the substance in kg, we get the heat released per unit kg or per unit gram, and that thing is known as calorific value. This was all for the theory part. So just wait for a while. Now we will move on to the question. Meanwhile, if you have a doubt, you can ask it here. Just wait for a while. We will be back in minutes. So, here is your first question. I will give you some time to solve it. Now, question says that the delta HF naught value for NO2 is given as 33.84 and for N2O4 it is given as 9.66 kilojoule per mole. Now, you have to find that what is your reaction, whether it is exothermic or endothermic or isothermic or isochoric. The reaction for which it is asking is dimerization of NO2. Now, first of all, write the complete reaction. How do you write the dimerization of NO2? So, 2 moles of NO2 will dimerize to form 1 mole of N2O4. Again, what you have to find that whether this reaction is exothermic or endothermic. Remember the equation that I said you to calculate the enthalpy of reaction. It is enthalpy of formation of product minus the enthalpy of formation of reactant. Remember, when you are doing that process, you have to look upon the stoichiometric coefficient. Got it? So this delta H formation of NO2 is giving for 1 mole, but during the reaction you are taking 2 moles of NO2. So can you please comment the answer? So which formula is the operating formula for this question? It is enthalpy of reaction of product minus the enthalpy of reaction of reactants, keeping in mind that the products and reactants should be multiplied along with the stoichiometric coefficient because the value is given for 1 mole. So what will be the answer for this question if this is true? It's a easy one. Again, this is a JEPYQ. Anyone who is willing to give the answer? So again, I am repeating the question. You are given with the enthalpy of formation of NO2, the enthalpy of formation of N2O4, and you have to find the enthalpy of reaction for the dimerization of N2O4 from NO2. What you have to do is to simply write the reaction, and then you have to use the enthalpy of formation of both the species to calculate it. Okay. So I am seeing one answer, exothermic. Let's see if it is correct or not. Now, okay, the correct answer is C, exothermic. Very good. How we'll solve it? It's very easy. I have told you each and everything in the theory part also, in the question part also. So this will be your reaction. 2 moles of NO2 reacting to give you 1 mole of N2O4. Now, in this case, your delta H naught reaction will be, so here you can write it as delta RH naught or delta H naught simply, both are applicable, no issue in that. Further, it will be enthalpy of formation of N2O4 minus enthalpy of formation of NO2. But rather than writing it as for the 1 mole, you have to write it for 2 mole, since 2 moles of NO2 are involved. So you have to multiply it with 2. If you put the values here, you will get it as 9.66 minus 2 into 33.84. Finally, if you calculate this, you will get it as minus 58.02 kilojoule. So is it clear to all of you? Any doubt in this? So send a thumbs up if you are understanding this part. It's a very easy one, so that I can get an idea that you are getting my question very well. See, the questions are very easy related to this thermochemistry. You have to simply put the values and calculate the answer, and just look for the negative or positive value to predict the nature of reaction if it is exothermic or endothermic. So is it clear to all of you? Anyone who is facing difficulty in this? Okay. Now moving forward, we can say that the enthalpy of reaction for this is, so why 2 is coming, because if you see here in the reaction itself, now the reaction is coming from the dimerization, and in this you can clearly see that 2 moles is written, whereas the enthalpy of formation for NO2 is given for per mole, see, kilojoule per mole. So you have to calculate it for 2 mole, So you are multiplying this thing by 2. Is it clear to you? Did you get where the 2 is coming from? Okay. Now we can clearly say that reaction is exothermic. So can you is it clear to you? Do you know now where 2 is coming from? Okay. Now moving on to the next question. In the reaction where Y is going to Z, your enthalpy is given as 100 kilocalorie per mole. For Z going to X, your enthalpy change is given as minus 80 kilocalorie per mole, and from Y to X, your enthalpy change is given as 20 kilocalorie per mole. You have to rank the enthalpy of formation for X, Y, and Z in the increasing order. Okay. So options are YXZ, YZX, XZY, and XYZ. What you have to do, you have to compare the enthalpy of formation for X, Y, and Z. Anyone who is getting the point how to solve it? Again, it's a easy one. Okay, let's see what is the correct answer. So the correct answer will be A, Y, X, and Z. Now coming back to the solution, we can write it for this reaction that delta H is equals to plus 100 kilocalorie per mole. So this is given for Y going to Z. So what we can say, if you write it in terms of enthalpy of formation, it will be enthalpy of formation of Z minus enthalpy of formation of Y. Is this step clear to you? So we are writing it from the first reaction. We know it. How can we write the enthalpy of reaction? We can write it by subtracting formation of product minus formation of reactant enthalpy. Is it clear to you? First step. Anyone who has a doubt in this step, first step? Okay. Now, similarly, we can apply this same logic onto X and Z. But before moving on to that, we can clearly say if this value is positive, that means that enthalpy of formation of Z is greater than enthalpy of formation of Y. Right? So, this is the first thing that we can get from the first equation. And it is very clear because we are getting a positive value. We can clearly say that the formation of Z has a greater enthalpy as compared to the formation of enthalpy of Y. Now, we can take the case of Z going to X and the enthalpy change is given as minus 80 kilocalorie per mole. Then the enthalpy of reaction can be written as the enthalpy of formation of X minus enthalpy of formation of Z, which will be minus 80 kilocalorie per mole. Finally, from this we can say that Z will be greater than X, right? So enthalpy of formation of Z will be greater than enthalpy of formation of X. Why? Because we are getting a negative value. So it is clear from this negative value that your formation of enthalpy for Z is greater than the X. Finally, from the last equation we can write that the enthalpy of formation of X minus enthalpy of formation of Y is equals to 20 kilocalorie per mole. That means the formation for X is greater than formation for Y. Now, if you compare these three results, so X is greater than Y, first of all, and Z is greater than X. Got it? Then we can write Z is greater than X is greater than Y. So this will be your final order. Is it clear to all of you? Anyone who has a doubt in this? Again, we use the simple formula to solve it. Is it clear to all of you? I hope this one is very simple to solve. You have to just use the enthalpy of reaction formula, and from the value given itself you can compare it. Any doubt in this point? So again I am repeating it. So in the first reaction we are going from Y to Z. So the enthalpy change for this reaction is given as 100 kilocalorie per mole. Now we know that enthalpy of reaction can be written in terms of enthalpy of formation of Z and Y. Product minus reactant. So enthalpy of formation of Z minus enthalpy of formation of Y is equals to 100. Now if you are getting a positive value in this equation, that means that this must be greater. So basically 4 minus 2 is always 2. Similarly, if you take 6 minus 5, if you are taking a greater value and from that you are subtracting a smaller value, you will always get a positive value, right? So from that point of view, your enthalpy of formation of Z is greater than of Y. Similarly, you can consider it for the second one, and similarly you can consider it for the third one. For the second one, you are getting a negative value, and that is clearly indicating that your enthalpy of formation of Z is greater. That is the reason you are getting a negative value. Got it? You have to simply compare the enthalpies of formation of X, Y, and Z, and you are doing it with the help of enthalpy of reaction. Got it? So from this logic, when the enthalpy of formation of Z is greater than X and X is greater than Y. Is it clear now? Now moving on to the next question. 2.1 gram of iron combines with sulfur, evolving 3.77 kilojoule. You have to find the heat of formation for FeS, and the unit should be in kilojoule per mole. The hint for you is that here you are combining iron and sulfur and it will give you FeS, right? So this value which is given 3.77 kilojoule is for 2.1 gram of Fe, but you have to find it for 1 mole of the formation of FeS. Got it? Again I am repeating my part. So the given data is for formation of for 2.1 gram of Fe reacting with sulfur to form 3.77 kilojoule, but you have to calculate it for the formation of 1 mole of FeS. Got it? Let's see. The correct answer is minus 100.5. How can we solve it? It's very simple. So when 2.1 gram of Fe is combined with S, the heat which is evolved is your 3.7 kilojoule. But in case of formation of 1 mole of FeS, what amount of Fe you should take? So if you write the complete reaction, then 1 mole of Fe will react with 1 mole of sulfur to give you 1 mole of FeS. It means that for formation of 1 mole of FeS, you must need 1 mole of Fe or 56 gram of iron. But you are given with the information of 2.1 gram of iron. You have to simply use the unitary method. So to calculate it for 56 gram, it will be 3.77 multiplied by 56 divided by 2.1. So for 1 gram it will be 3.77 by 2.1, and for 56 gram it will be 3.77 by 2.1 into 56. As simple as that. Okay, you get my point? So what did I say? You have to find the enthalpy of formation for 1 mole of FeS. Now 1 mole of FeS is formed from 1 mole of iron. So basically you have to calculate the heat release that is formed when 1 mole of iron is reacting to form 1 mole of FeS. Now it is given for 2.1 gram, which is 3.77. So for 1 gram it will be 3.77 by 2.1, and for 56 gram it will be 3.77 into 56 by 2.1. Now, since the heat is evolved in the formation of FES, therefore we can write it in negative value. See, it is written in the question that heat is evolved as 3.77. So this will also evolve heat but in a greater amount. Now, next question. The enthalpy of formation, the standard enthalpy of formation for carbon dioxide, carbon monoxide and H2O are minus 393.5, minus 110.5 and 241.8, all in the negative sense respectively. You have to calculate the standard enthalpy change for the given reaction where we are reacting carbon dioxide with hydrogen to form carbon monoxide and water. So how you will calculate it? It's very simple. You have to calculate the standard enthalpy of reaction. You know how to calculate it. You have to simply subtract enthalpy of formation of product minus enthalpy of formation of reactant. You are given with enthalpy of formation for each and every species. For CO2 it is given, for CO it is given, for H2O it is given. But for one thing it is not given, which is your hydrogen. I have told you it in the start that for standard states it is taken as 0. So you have to see that whether your hydrogen is it in the standard state or not, and then you can take it as 0. And further you can calculate your final answer. So let's see who can solve it. So if you are getting my lecture, just send a thumbs up who all are attending it. And if you have a doubt, just post it here. So it's a very easy question. You have to calculate the enthalpy of reaction, whose formula is standard enthalpy of formation of product minus standard enthalpy of formation of reactant. Two things are noteworthy here. First of all, these are all given for 1 mole. You have to calculate it for the specific mole according to the reaction. And second thing, you must take the enthalpy of formation for hydrogen as 0 because it is in the standard state. So all of you who are watching the lecture, please send a comment section, thumbs up in the comment section if you are getting my lecture very well. Okay, so let's see the correct answer. The correct answer will be D, 41.2 kilojoule. How we'll calculate it? Let's see. First of all, this is your reaction for standard enthalpy of formation for carbon dioxide, which is C plus O2 giving us CO2. So this will be your equation. Got it? So this is given as minus 393.5 kilojoule per mole. Okay. Similarly, for carbon monoxide, it is given as minus 110.5 kilojoule per mole. And then after for H2O, it is given as minus 241.8 kilojoule per mole. Now what are the products here? Here we have carbon monoxide and water as the product. So we will first of all add the enthalpy of formation of products, which is your carbon monoxide and your water. Then after we will subtract that thing. From that we will subtract the standard enthalpy of formation of carbon dioxide, which is given here as minus 393.5. Okay, you don't have to worry about hydrogen because hydrogen is it in the standard state. Therefore, the enthalpy of formation for hydrogen will be taken as 0. So as I said, you have to add equation 2 and 3 and subtract 1 from that part. Now it will give you the final equation, and the calculation underlying it will be standard enthalpy of formation of carbon monoxide product plus the standard enthalpy of formation of water minus the standard enthalpy of formation of carbon dioxide. You don't have to take H2 because H2 is in the standard state and its standard enthalpy of formation will be 0. Now next, if you put all the values here and calculate this thing, you will get it as 41.2 kilojoule. So this is your final standard enthalpy of reaction for the given reaction, which is CO2 plus H2O to give us CO plus H2O. Now, next question. Consider the reaction given here. Two reactions are given. First is the formation of CO2 from carbon and oxygen, whose enthalpy is given as X. Similarly, the formation of CO2 from carbon monoxide and half mole of O2, whose enthalpy change is given as Y. You have to find the enthalpy of formation of CO. Now, what equation can be considered as enthalpy of formation from CO? When you form 1 mole of CO and from its element in the stable state. So what are the elements involved in CO? It is carbon and oxygen. Okay? But remember, you have to form only 1 mole. So for that you will take 1 mole of carbon plus half mole of O2 to give 1 mole of carbon monoxide. So that is the equation that you will use. So let's see if you can solve it or not. What you have to find? You have to find the enthalpy of formation of carbon monoxide. What you will do is simply play with these two reactions, these two thermochemical equations, to form the final required equation. So first of all, write the final required equation and then try to just play with these two reactions to get that final equation, and you will easily get your answer. Okay? So if you are facing any difficulty, then you can ask it here. Just try to think of it. For the standard enthalpy of formation of CO, what you should take? You should take 1 mole of carbon plus half mole of O2 to give you 1 mole of CO. Now, what do you see in the final equation? You need carbon monoxide on the right hand side. Therefore, there must be a scene. You must need to reverse this reaction. Okay. So I hope this much hint is very much enough for you to solve the question. Now moving on to the answer. The correct answer is A, X minus Y. Let's see how. So what you have to get? You have to get C plus half O2 to give CO. The given equations are C plus O2 giving us CO2 whose enthalpy change is X, and CO plus half O2 which is CO2 whose enthalpy change is Y. Now the heat of formation of CO is C plus half O2 giving us CO. If you just subtract these two equations, what will happen? You will just reverse this one. Why? Because you are taking a negative sign here against Y. So whenever you take a negative sign, if you add it, it will be simply added. But when you subtract it, the equation gets reversed. So this Y is having a negative value against it, and it will be reversed to give us CO2 giving us CO plus half O2. Then after, if you subtract these two equations, what will happen? CO2 and CO2 will get cancelled out. Carbon will be remained in the equation, and O2 minus half O2 will give you half O2 again. Got it? Therefore, the correct answer is X minus Y. Next question. On the basis of thermochemical data, you have to calculate the value of enthalpy of formation for OH minus ion. Remember, the enthalpy of formation for H plus aqueous is taken as 0, and two equations are given here. First is the decomposition of water to form the H plus and OH minus ion, whose enthalpy change is 57.32. Second, the enthalpy of water is given from hydrogen and oxygen. You have to find the enthalpy of formation of OH minus. Again, you have to rearrange these two equations to get it for the enthalpy of formation of OH minus. Okay. So this was asked in JEE Mains 2009. So let me solve it for you. If you try it by yourself, you can do it along with me. Or if you are facing difficulty, you can see the solution along with me. The correct answer will be B, minus 228.88 kilojoule. Now, moving on to the solution, consider the heat of formation of H2O. So this will be your thing, H2 plus half O2 giving H2O, because here water is being formed from its elements and elements are in their most stable state and 1 mole of water is formed. And its value is given as minus 286.20 kilojoule. Next thing, you can write it directly as the enthalpy of formation of liquid water is minus 286.20. So this reaction enthalpy is equals to the standard enthalpy of formation of liquid water. Next, continuing with the solution, we have other equation as ionization of water, because your water which is in liquid form is dissociating to form H plus and OH minus in the aqueous form. And in this case, the enthalpy change is given as 57.32. Since it is forming ions of 1 mole of the water, so we can call it as enthalpy of ionization. Next, you have to find enthalpy of reaction, enthalpy of formation of OH minus. How you will do it? So for this, you should use this equation. Now, for this reaction, what will be the enthalpy change? You can write it as enthalpy of formation of H plus, which is your product, plus enthalpy of formation of OH minus, again your product, minus enthalpy of formation of water. So this will be your standard enthalpy of reaction for this given equation, right? Now what values do you have? You have the enthalpy of formation of water already, which is 57.32 kilojoule. Then the enthalpy of formation of H plus is given as 0. Next, the overall enthalpy of reaction is also given, which is 57.32. If you put all this value, you only need to calculate the enthalpy of formation of OH minus. So this thing can be calculated by solving a simple linear equation to give you minus 228.88 kilojoule as your answer. So this was all for today's class. Thank you for joining the session. I hope you enjoyed it.
Hello student. So in today lecture we are going to discuss the theory of binomial theorem. This is our disclaimer part, and you can see that this is a trend analysis according to last 5 year, and the chapter weightage is 4.26%, and this is a yearly question distribution. You can see that in 2024 there is one question from this chapter based on the topic coefficient of the expansion 1 plus x ki power n, right? And the difficulty level is easy. Similarly, in 2022 there is two question from this chapter based on the topic combination and the coefficient of the expansion of 1 plus x ki power n, and the difficulty level is average, right? And in 2023 also there is two question from this chapter based on the topic binomial expansion, and the difficulty level is average, right? Similarly, in 2021 there is one question from this chapter based on the topic to obtain the remainder, right? And the difficulty level is average. So this is our index. So first we will discuss about the binomial theorem. After that we will discuss the binomial theorem for positive index. Then we will discuss the some properties of binomial coefficient. And next we will discuss the application of binomial theorem, right? And then we will discuss the binomial theorem for negative or rational index, means binomial theorem for negative or rational index, right? And then finally we will discuss the principle of mathematical induction, right? So let's start with the binomial theorem. So what is binomial theorem? So the binomial theorem is a fundamental concept in algebra that describes how to expand power of binomial expression such as x plus y ki power n, right? Where n is a non-negative integer. So according to the theorem, the expansion of x plus y ki power n results in a sum of the terms of the form ax ki power b y ki power c, right? Where b and c are non-negative integer that satisfying the sum relation. What is that relation? They are satisfying the relation b plus c equals to n, right? And each term in the expansion has a coefficient a, right, which is known as a binomial coefficient, right? And now we are going to discuss binomial theorem for positive integer. See that an algebraic expression consisting of two terms with positive or negative sign between them is called binomial expression, right? So a binomial is just a math phrase with two parts or terms in it, right? It could be x plus 2 because x plus 2 we have a two terms, right? Or it can be a minus b because you can see that in a minus b also we have a two terms. So here by just mean two, right? And how can you count the like it has a two part? So with the help of positive and negative sign, right? See that in x plus 2 we have a positive sign between x and 2, so that's why we will say that here we have a two terms. So let's suppose we have a plus b plus c, so here we have a three terms, right? Because here we have a positive sign between a and b, and also we have a positive sign between b and c, right? So that's why here we have a three terms, right? So like it is not necessary there is positive sign, it can be negative sign also, right? So here we have discussed that by just mean two, right? So let's suppose if n is any positive integer, so then x plus a ki power n equals to nc0 times x ki power n plus nc1 times x ki power n minus 1 times a plus dot 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 plus ncn times a की power n, right? So we can write this expression as into the summation form. So when we will write this into the summation form, so we will get that x plus a की power n equals to summation r equals to 0 to n ncr times x की power n minus r times a की power r, right? Where x and a are real and complex number, right? And the coefficient of terms equidistant from the beginning at the end, right, are equal, right? So what is the meaning? So it means that the number in front of the terms are symmetrical, right? So we can say that the number at the start is same as the number at the end, right? And also we can say that the second number is the same as the second to last number, and so on, right? Means they mirror to each other, right? So similarly we have discussed the formula of x plus a की power n, right? So similarly we can write the formula of x minus a की power n. So you just need to replace plus a with minus a, right? So when you will do this, so you will get the formula of x minus a की power n equals to nc0 x की power n minus nc1 times x की power n minus 1 times a plus dot 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 plus minus 1 की power n ncn times a की power n, right? So similarly you can write what will the formula of 1 plus x की power n, right? Because we know that the formula of x plus a की power n. So in this formula you just need to put x equals to 1 and a equals to x, right? So when you will put x equals to 1 and a equals to x, so you will get the formula of 1 plus x की power n, that is equals to nc0 plus nc1 times x plus nc2 times x square plus dot 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 ncn times x की power n, right? And the total number of terms in the expansion x plus a की power n is n plus 1, right? So let's suppose if the power is 3, so you get 4 terms, right? If the power is 5, so you get 6 term, right? And if n is positive integer, then the number of terms in the expansion of x plus y plus z की power n is n plus 1 times n plus 2 divided by 2, right? This is a for 3 part expansion, right? So the number of terms in the expansion of x plus a की power n plus x minus a की power n, right? So it is based on the value of n. It means that if n is even, so we will get the different number of terms. If n is odd, so we will get the different number of terms, right? So here we have a two cases. So if n is even, so we will get total n plus 2 by 2 number of terms, right? And if n is odd, so we will get n plus 1 by 2 terms, right? And the number of terms in the expansion of x plus a की power n minus x minus a की power n equals to the, it is also based on the value of n. It means that if n is even, so we will get the different value. If n is odd, so we will get the different value, right? So if n is even, so we will get the total number of terms equals to n by 2, and if n is odd, so we will get the total number of terms equals to n plus 1 by 2, right? So here we have discussed that what is the binomial expression. Then we have discussed that how to do the binomial expansion of x plus a की power n, right? And then we have discussed that how to count the total number of terms in the expansion of x plus a की power n, right? And then we have discussed that the number of terms in the expansion of x plus a की power n plus x minus a की power n, right? And then in the last we have discussed that the number of terms in the expansion of x plus a की power n minus x minus a की power n, right? Okay, so now we are going to discuss the general term and middle term of binomial theorem, right? So let r plus 1th term be the general term in the expansion of x plus a की power n. So here we are assuming that let r plus 1th term be the general term in the expansion of x plus a की power n. Then we can calculate what will the value of r plus 1th term, that is tr plus 1 equals to ncr times x की power n minus r times a की power r, right? So this will be the value of r plus 1th term, right? So if expansion is x minus a की power n, then the value of the general term will change. So what will the value of general term? So then the general term is minus 1 की power r times ncr times x की power n minus r times a की power r, right? So see that if you are doing the expansion of x plus a की power n, right, then in that case the value of r plus 1 term will be tr plus 1 equals to ncr times x की power n minus r times a की power r, right? But if you are doing the expansion of x minus a की power n, so in that case the value of r plus 1 term will be tr plus 1 equals to minus 1 की power r times ncr times x की power n minus r times a की power r, right? So now we are going to see that the middle term in the expansion of a plus x की power n, right? So for that we need to consider the two cases, right? So in the first case, if n is even, so what will be the middle term? So if n is even, so in that case n by 2 plus 1 term is the middle term, right? So let's suppose n equals to 4. So in that case the middle term will be 4 by 2 plus 1, that is third term, right? And now we are going to see the case 2. So in the case 2, if n is odd, so in that case n plus 1 by 2th term and n plus 3 by 2th term are middle terms, right? So it means that we can say that if n is even, so in that case we will get a single middle term, but if the value of n is odd, so in that case we will get a two middle term, that is n plus 1 by 2th term and n plus 3 by 2th term, right? So now we are going to discuss the next one. So p plus 1th term from int equals to the n minus p plus 1th term from beginning, right? So this is known as a symmetric property, right? Means that p plus 1th term from the int equals to the n minus p plus 1th term from beginning, right? So for making a term independent of x, we put r equal to 1 in the general term of x plus a की power n. So what is the general term of x plus a की power n? So the general term we have assumed that r plus 1 term, and we have discussed that tr plus 1 equals to ncr x की power n minus r times a की power r, right? And if you want to make this term independent of x, so what you will do, you can put r equal to n, and if you will put r equal to 1, so what you will get, you will get that t, you will get this value equals to ncn x की power, in place of r we will put n, right? So ncn times x की power n minus n times a की power n, so this will equals to ncn times x की power 0 times a की power n, right? So we will get ncn times a की power n, right? So if we will put r equals to n in the general term of x plus a की power n, so what we will get, we will get the general term as ncn times a की power n, right? And that is independent of x, because in NCn times a ki power n, we don't have any terms of n. We don't have any term of n, right? So that's why we can say that this NCn times a ki power n is independent of x. And now we are going to discuss one note. So see that if the coefficient of rth and r plus 1th and r plus 2th term of 1 plus x ki power n are in AP, then in that case this condition will hold. What is the condition? The condition is that n square minus 4r plus 1 times n plus 4r square equals to 2, right? So here we have discussed what is the general term, means how we can calculate like r plus 1 term, right, in the expansion of x plus a ki power n. And then we have discussed that how we can calculate r plus 1 term in the expansion of x minus a ki power n, right? And then we have discussed that how we can calculate the middle term if the value of n is odd, and if the value of n is even, then in that case how we can calculate the middle term, right? So now we are going to discuss about the greatest term. See that if tr and tr plus 1 be the rth and r plus 1th term in the expansion of 1 plus x ki power n, it means that if tr is the rth term and tr plus 1 is the r plus 1th term in the expansion of 1 plus x ki power n, so then if we will calculate the ratio, it means that if we will calculate the value of tr plus 1 divided by tr, so what we will get? We will get this value equals to ncr times x ki power r divided by nc r minus 1 times x ki power r minus 1, right? And after the simplification, what we will get? We will get this value equals to n minus r plus 1 divided by r times x, right? So see that let numerically tr plus 1 be the greatest term in the above expansion, right? So for tr plus 1 to be the greatest term, what we require? We require that tr plus 1 greater than tr, right? So we can say that tr plus 1 divided by tr is greater than 1 in the above expansion. So in that case we can say that tr plus 1 is the greatest term, right? So for that n minus r plus 1 divided by r times mod x should be greater than equals to 1, right? Or what we can say? That we can say that r is less than equals to n plus 1 divided by 1 plus mod x times mod x, right? And we will say that this is equation number 1, right? See that now we are going to put the value of n and x in equation 1, right? So what we will get? We will get that r is less than equals to m plus f, or r is less than m. See that the right hand side of equation 1, it is not necessary that you will get the integer value, right? You can get any fraction value, right? Let's suppose that you are getting this value equals to 5 by 2. So what you can write? You can write 5 by 2 as 2 plus 1 by 2, and here we can say that this 2 is an integer and 1 by 2 is a fraction, right? So that's why we can say that r is less than equals to m plus f, where m is a positive integer and f is a fraction, or we can say that r is less than equals to m, right? So and where f lie between 0 to 1, right? So from the equation 1 we will get this equation, r is less than equals to m plus 1, or r is less than equals to m, right? So see that if r is less than equals to m plus f, so in that case the greatest term is tm plus 1, right? And if r is less than equals to m, so in that case the greatest terms are both tm and tm plus 1, right? And they are equal, right? So what we can say? We can say that this means that the terms with the highest coefficient occur around the value of r given by the above expression, right? And now we are going to discuss the next point. So the next point is that the greatest coefficient in the binomial expansion of a plus x की power n refer to the coefficient of middle term, right? And these are the coefficient of the term that are closest to the center of expansion. So we will get two case. What is the two case? So if n is even, so there is only one middle term and its coefficient is the greatest, right? But if n is odd, so in that case there are two middle terms and their coefficient are equal and the greatest, right? So what we can say that, we can say that if n is even, so in that case we will get a single greatest coefficient, right? But if n is odd, so what we can say that, we can say that if n is odd, so in that case we will get a two terms where the coefficient are the greatest coefficient, right? Why? Because we know that if n is even, so in that case we have only one middle term, and if n is odd, so in that case we have a two middle terms, right? So that's why. Yeah, so here we have discussed that what is the greatest term, right? And then we have discussed about the greatest coefficient. So now we are going to discuss the properties of binomial coefficient. So in the binomial expansion of 1 plus x की power n, the first property is that 1 plus x की power n equals to nc0 plus nc1 times x plus nc2 times x square plus dot 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 plus ncr times x की power r plus dot 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 ncn times x की power n, right? Where nc0, nc1 dot 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 ncn are the coefficient of various power of x, are called the binomial coefficient, and it is also written as c0 c1 dot 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 cn, right? And now we are going to discuss the next properties, that we can say that symmetry property. What is that? ncr equals to nc n minus r, right? So this indicate that the binomial coefficient are symmetric around the middle terms too. And the next point is that ncr1 equals to ncr2, right? So we can say that this is a uniqueness of coefficient, right? So if ncr1 equals to ncr2, so this implies that r1 equals to r2 or r1 plus r2 equals to n, right? So the next property is that addition property, we can say that. So this property says that ncr plus ncr minus 1 equals to n plus 1 cr, right? And the next property is that ncr divided by ncr minus 1 equals to n minus r plus 1 divided by r, right? And the next property is that r times ncr equals to n times n minus 1 c r minus 1, right? And then the next property we have ncr divided by r plus 1 equals to n plus 1 c r plus 1 divided by n plus 1, right? You can prove this property with the help of the previous property, that is r times ncr equals to n times n minus 1 c r minus 1, right? So the next property is that c0 plus c1 plus c2 plus dot 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 plus cn equals to 2 की power n, right? And how you can prove this property? See that you know that the expansion of 1 plus x की power n, right? So what will be the expansion of 1 plus x की power n? So if you will do the expansion of 1 plus x की power n, so what you will get? You will get nc0 plus nc1x plus dot 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 plus ncn x की power n, right? So in place of x you just need to put 1, right? So if you will put x equals to 1, so in the left hand side what you will get? 1 plus 1 की power n, right? Equals to what you will get? You will get nc0 plus nc1 plus nc2 plus dot 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 ncn, right? So in the left hand side you will get 2 की power n, right? And in the right hand side, in like you can say nc0 equals to c0, right? So you will get c0 plus c1 plus c2 plus dot 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 cn, right? So you can show that c0 plus c1 plus c2 plus dot 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 plus cn equals to 2 की power n, right? And similarly, the second property we have c0 plus c2 plus c4 plus dot 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 equals to c1 plus c3 plus c5 plus dot 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 equals to 2 की power n minus 1, right? And the next property we have c0 minus c1 plus c2 minus c3 plus dot 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 plus minus 1 की power n times cn equals to 0, right? So how you can prove this property? You just need to write the expansion of 1 minus x की power n, right? And then you just need to prove x equals to 1, right? So if you will do that, so you will get that c0 minus c1 plus c2 minus c3 plus dot 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 plus minus 1 की power n times cn equals to 0, right? This is same as the property 1, c0 plus c1 plus c2 plus dot 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 plus cn equals to 2 की power n. You can prove this similar to the first one. And the next property is that c0 square plus c1 square plus c2 square plus dot 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 plus cn square equal to 2n cn equals to 2n factorial divided by n factorial whole square, right? And then the next property we have c0 square minus c1 square plus c2 square minus c3 square plus dot 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 equals to, so we will get two value. So first, if n is even, so in that case we will get this value equals to minus 1 की power n by 2 times nc n by 2, right? And if n is odd, so in that case you will get this value equals to 0, right? And the next property we have c0 times cr plus c1 times cr plus 1 plus dot 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 plus cn minus r times cn equals to 2n cn minus r, right? Equals to 2n factorial divided by n minus r factorial times n plus r factorial, right? And the next property we have c1 minus 2c2 plus 3c3 minus dot 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 equals to 0, right? And the next property we have c0 plus 2c1 plus 3c2 plus dot 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 plus n plus 1 times cn equals to n plus 1 times 2 की power n minus 1, right? And the next property we have c0 minus c2 plus c4 minus c6 plus dot 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 equals to square root of 2 की power n times cos n pi by 4, right? And the last property we have c1 minus c3 plus c5 minus c7 plus dot 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 equals to square root of 2 की power n times n pi by 4, right? So here we have discussed the properties of binomial coefficient, right? So you just need to learn all this property, right? So now we are going to discuss the application of binomial theorem, right? So for that we will discuss the RF factor relation. See that here we are going to discuss the problem involving root a plus b की power n, right? So if you will do the expansion of root a plus b की power n, so you will get this is equals to I plus f, but there is some condition, right, where I and n are positive integer and also there are some other condition. What is that? F lie between 0 and 1, right? And mod of a minus b square equals to k, and mod of root a minus b is less than 1, right? So now we are going to discuss each and every term in detail, right? So here, what is the meaning of root a plus b ki power n, right? So this is a binomial expression raised to the power n, right, where a and b are real number and n is positive integer, right? And what is a I? So this represent the integer part of the expression root a plus b ki power n, that is the part of the expression that is an integer, right? And what is f? So this is the fractional part of the expression, so that we have given the one condition. What is that? The value of f lie between 0 and 1, right? And then we have given that mod a minus b ka whole square equals to k. So this implies that a is close to b square, but there is a small difference of k, which is a positive constant, right? And then we have given that mod of root a minus b is less than 1. So this condition ensure that root a is close to b, right? So here we have discussed that what is RF factor relation, right? So now we are going to discuss the divisibility problem. So what is that? See that in the expansion 1 plus alpha ki power n, we can conclude that 1 plus alpha ki power n minus 1 is divisible by alpha. That is, it is multiple of alpha. How we can say that? See that if you will do the expansion of 1 plus alpha ki power n, so what you will get? You will get that nc0, what you will get? You will get nc0 plus nc1 times alpha plus dot 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 plus ncn times alpha ki power n, right? And we know that the value of nc0 is 1, so we can say that 1 plus alpha ki power n equals to 1 plus nc1 times alpha plus dot 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 plus ncn times alpha ki power n, right? And if we will take 1 from right side to left side, so what we will get? We will get that 1 plus alpha ki power n minus 1 equals to nc1 times alpha plus dot 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 ncn times alpha ki power n, right? And see that in the right hand side, each and every term there is some power of alpha. So what we can say? That we can say that finally we can say that 1 plus alpha ki power n minus 1 is divisible by alpha, right? Because this value 1 plus alpha ki power n minus 1 equals to nc1 alpha plus dot 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 ncn times alpha ki power n, right? And this is divisible by alpha because there is some power of alpha in each and every term, right? So that's why finally we can say that ki 1 plus alpha ki power n minus 1 is divisible by alpha, that is, it is a multiple of alpha, right? So here we have discussed the divisibility problem. So now we are going to discuss the differentiability problem. So this is the application of binomial theorem, right? So see that sometimes to generalize the result we use the differentiation, right? So see that. So let's suppose we have a expansion of 1 plus x ki power n, that is equals to nc0 plus nc1 times x plus nc2 times x square plus dot 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 plus ncn times x ki power n, right? So on differentiating with respect to x, what we get? So when we will differentiate both sides of the above equation with respect to x, so we will get n times 1 plus x ki power n minus 1 equals to 0, because the first term nc0 is constant. 0 plus nc1 plus 2 times x times nc2 plus dot 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 plus n times ncn times x ki power n minus 1, right? So if you will put x equals to 1, so we will get that the left hand side as n times 2 ki power n minus 1, and the right hand side as this is equals to nc1 plus 2 ki power n c2 plus dot 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 n की power and cn, right? So now we are going to discuss the binomial theorem for negative or rational index. So see that, let n be a rational number and x be a real number such that mod of x less than 1. Then 1 plus x की power n equals to, we will get 1 plus nx plus n times n minus 1 divided by 2 factorial times x square plus n times n minus 1 times n minus 2 divided by 3 factorial times x cube plus dot dot dot, right? And if n is a positive integer, then 1 plus x की power n contains n plus 1 terms, that is a finite number of terms, right? When n is any negative or rational number, so in that case the expansion of 1 plus x की power n contains infinitely many terms, right? So when n is positive integer, then the expansion of 1 plus x की power n is valid for all values of x, right? But if n is any negative integer or rational number, so in that case the expansion of 1 plus x की power n is valid for the values of x that satisfying the some condition. What is that condition? The condition is that mod of x is less than 1, right? So we can say that the expansion of 1 plus x की power minus 1 equals to 1 minus x plus x square minus x cube plus dot dot dot, right? And the second things, the expansion of 1 minus x की power minus 1 equals to, we will get 1 plus x square plus x cube plus dot dot dot. And similarly we will get the expansion of 1 plus x की power minus 2 equals to 1 minus 2x plus 3x square minus 4x cube plus dot dot dot, right? And similarly we will get the expansion of 1 minus x की power minus 2 equals to 1 plus 2x plus 3x square plus 4x cube plus dot dot dot, right? So here we have discussed the binomial theorem for negative or rational index, right? So now we are going to discuss the principle of mathematical induction. So first we will see that what is mathematical induction. So mathematical induction is a method of mathematical proof typically used to establish that a given statement is true for all natural number, right? So in algebra there are certain results that are formulated in terms of n, where n is a positive integer, right? So such result can be proved by a specific technique which is known as the principle of mathematical induction, right? So what is the step that is in mathematical induction? So we are going to see discuss in general. So in general there are two cases. First is base case, then inductive step, right? So what is the base case? So first we verify that the statement is true for the smallest value of n, right? Usually we will take n equals to 1, right? And next we assume that the statement is true for some arbitrary positive integer k, right? And then we try to prove that the statement must also be true for k plus 1, right? So this step involves showing that if the statement hold for one value, so it must hold for the next value, right? And then we conclude that the statement is true for all positive integer n, right? So this is all about the mathematical induction, how we can show how we can prove any result with the help of the mathematical induction, right? So here we are going to discuss the first principle of mathematical induction. So it consists of the following three steps. What is that? See that. The first step is that actual verification of the proposition for the starting value of I, right? And the step 2 is that assuming the proposition to be true for k where k greater than I, and we try to prove it is true for the value k plus 1, which is the higher integer, right? Because we have assumed this is true for k, and what is the next higher integer of k? K plus 1. That's why we try to prove this result is true for k plus 1. And step 3, to combine the above two steps, let Pn be a statement involving the natural number n such that, see that P1 is true, means that is Pn is true for n equals to 1. This is, we have assumed that. So this is a base case, we can say that. And the next, Pm plus 1 is true whenever Pm is true. So we have assumed Pm is true and we try to prove that Pm plus 1 is true, right? So first we need to show that P1 is true, that is Pn is true for n equals to 1. And then second, we have assumed that it is true for n equal to 1, m equal to m, and we try to prove that it is true for n equals to m plus 1, right? That is Pm is true, this implies that Pm plus 1 is true, right? So we can say that then Pn is true for all natural number n, right? And the last point is that the product of r conjugate to integer is divisible by r factorial, right? So here we have discussed that the first principle of mathematical induction, right? Means how we can apply the mathematical induction to prove any result, right? Means to prove any theorem, you can say that. Now we are going to discuss the summary of the binomial theorem. So we can say that the binomial theorem is an algebraic expression consisting of two terms connected by a plus or minus sign, right? So according to this theorem, any expression of the form x plus y की power n can be expanded into a sum of terms of the form ax की power b times y की power c, where the exponent b and c are non-negative integer and they are satisfying the condition. What is the condition? The condition is that b plus c equals to n, right? And the coefficient a of each term is known as the binomial coefficient, right? And then we have discussed that algebraic expression consisting of two terms, positive or negative sign between them, is called the binomial expression, right? So it can be a plus b, it is also example of binomial expression, right? A minus b, it is an also example of binomial expression, but a plus b plus c, it is not an example of binomial expression, right? And then we have discussed that the number of terms in x plus a की power n minus x minus a की power n equals to n by 2 if n is even, and n plus 1 by 2 if n is odd, right? And then we have discussed about the general term and middle term of the binomial. And then we have discussed about the greatest term, right? And then we have discussed the property of binomial coefficient. And then we have discussed the application of binomial theorem, right? So in which we have discussed the RF factor relation, right? And then in which we have discussed the divisibility problem, right? And also we have discussed the differentiability problem, right? And then we have discussed the binomial theorem for negative or rational index. And then finally we have discussed the principle of mathematical induction, right? And then we have discussed the first principle of mathematical induction, right? So wait for 2 minutes, student. We are going to solve a practice question based on the theory which we have discussed. So wait for 2 minutes. Okay, student. So let's discuss the some practice question based on the theory which we have discussed. So this is our disclaimer. So we are going to solve the practice question, right? So this is our first question. So in this question we have given that if 1 plus ax ki power n equals to 1 plus 8x plus 24x cube plus dot dot dot, then we need to find that what will be the value of a and n, right? And we have given four options. So the first option we have given 2 and 4. The second option we have given 2 comma 3, and the third option we have given 3 comma 6, and the last option we have given 1 comma 2, right? So we need to find that which option is correct. So everyone please try to solve this question, then we will discuss the solution. Everyone please try to solve this question. So in this question you just need to write the expansion of 1 plus ax ki power n, right? And then try to compare the coefficient, right? Everyone please try to solve. It does not matter like you are getting wrong answer or correct answer plus, but please try to solve and response. Yeah. Okay, let's start the solution. So our correct answer is A, right? So now we are going to discuss the solution how A will be true, right? So what we have given that we have given the 1 plus ax ki power n equals to 1 plus 8x plus 24x square plus dot dot dot, right? So if we will write the expansion of 1 plus ax ki power n, so what we will get, we will get that 1 plus n by 1 times ax plus n times n minus 1 divided by 1 times 2 times a square times x square plus dot 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 equals to 1 plus 8x plus 24x square, right? Because in the question we have given that 1 plus ax ki power n equals to 1 plus 8x plus 24x square plus dot dot dot, right? So we can write the expansion of 1 plus ax ki power n, right? Then equate it equals to 1 plus 8x plus 24x square plus dot dot dot, right? Then we just need to compare the coefficient of x and x square, right? So when we will compare the coefficient of x, so what we will get, we will get that n equals to 8, right? And when we will compare the coefficient of x square, so what we will get, we will get that n times n minus 1 divided by 1 times 2 times a square equals to 24, right? So from here we will get that na times n minus 1 times A equals to 48, right? So we can write this as Na times Na minus A, right? And we know that we have the value of Na, that is equals to 8. So when we will put this value, so what we will get? We will get this equation as 8 times 8 minus A equals to 48, right? So from here we will get the value of 8 minus A equals to 6, right? And from here we can calculate the value of A, that is equals to 8 minus 6, which is equals to 2, right? So here we have calculated the value of A equals to 2, right? And we know that Na equals to 8, right? So we are just going to put this value of A into that equation, right? So from there we will get the value of n equals to 4, right? So here we have calculated the value of A and n, right? And we are getting A equals to 2 and n equals to 4. So now we are going to discuss the second question. So in this question we have given that the coefficient of x ki power n in the expansion of 1 plus x ki power 2n and 1 plus x ki power 2n minus 1 are in the ratio, right? We need to find the ratio. So we have given four options. So the first option we have given 1:2, and the second option we have given 1:3, and the third option we have given 3:1, and the last option we have given 2:1, 2:1, right? So we need to find that which option is correct, right? So everyone please try to solve this question, then we will discuss the solution. Everyone please try. And if you are facing any difficulty, you can ask in the comment box. Everyone please try to solve. Anyone got the answer? Anyone got the answer? Okay, let's discuss the solution. So the correct answer is D, right? So now we are going to discuss the solution how D will be true. So we know that the coefficient of x ki power n in 1 plus x ki power 2n equals to 2n cn, and the coefficient of x ki power n in 1 plus x ki power 2n minus 1, which is equals to 2n minus 1 cn, right? So here we have found that the coefficient of x ki power n in 1 plus x ki power 2n and 1 plus x ki power 2n minus 1, right? So we just need to find their ratio, right? So the required ratio equals to 2n cn divided by 2n minus 1 cn, right? So this is equals to 2n factorial divided by n factorial times n factorial, and this is divided by 2n minus 1 factorial divided by n factorial times n factorial, right? And after simplification this will equals to 2n times 2n minus 1 factorial divided by n times n minus 1 factorial whole divided by 2n minus 1 factorial divided by 2n n minus 1 factor, right? And when we will simplify this, so we will get this ratio as 2:1, right? So here we have calculated the ratio of coefficient of x ki power n in the expansion 1 plus x ki power 2n and 1 plus x ki power 2n minus 1, that is equals to 2:1. So now we are going to discuss the next question. So in this question we need to find the value of 1.002 ki power 12 up to fourth place of decimal, right? And we have given four options. So the first option we have given 1.0242, the second option we have given 1.0245, and the third option we have given 1.0004, and the last option we have given 1.0254, right? So we need to find that which option is correct. So everyone please try to solve, then we will discuss the solution. Everyone please try to solve. So in this you just need to write the expansion of 1 plus 1.002 ki power 12. You can write this as 1 plus 0.002 ki power 12, right? So you just need to write the expansion of this, and you just need to consider fourth term, right? And then you just need to calculate the value. Yeah. So everyone please try to solve this. Anyone got the answer? Okay, let's discuss the solution. So the correct answer is A, right? So now we are going to see the solution how A will be true, right? So we have 1.002 ki power 12, right? Or it can be rewritten as, we can rewrite this as 1 plus 0.002 ki power 12, right? So we are going to write the expansion of 1.002 ki power 12, because we can rewrite this as 1 plus 0.002 ki power 12, right? So we know that what is the expansion of 1 plus x ki power n. What is that? We know that this expansion is nc0 plus nc1 times x plus nc2 times x square plus dot dot dot, right? So in place of x we have 0.002, right? So this will equals to 1 plus, in place of n we have a 12, so 1 plus 12c1 times 0.002 plus 12c2 times 0.002 का whole square plus 12c3 times 0.002 का whole cube, right? And since we want the answer up to 4 decimal places, and as such we have left further expansion, right? So we only need to consider these 4 terms, right? And so we will neglect the higher powers, right? So we will get the value of 1.002 ki power 12 equals to 1 plus 12 times 0.002 plus 12 times 11 divided by 1 times 2, because this is the value of 12c2, right? Times 0.002 ka whole square plus 12 times 11 times 10 divided by 1 times 2 times 3 times 0.002 ka whole cube, right? So when we will simplify this, so we will get this value as 1 plus 0.024 plus 2.64 times 10 ki power minus 4 plus 1.76 times 10 ki power minus 6, right? So when we will calculate this value, so finally we will get the value of 1.002 ki power 12 equals to 1.025, 42, right, up to fourth place of decimal, right? See that here you need to calculate this value up to the fourth place of decimal, right? So that's why here we have only considered the fourth term, right? So if you need to calculate the five place of decimal, so you just need to consider the five terms, right? So now we are going to discuss the next question. So in this question we need to find the coefficient of x ki power 4, right, in the expansion of 1 plus x square plus x cube ki power n, and we have given four options. So the first option we have given nc4, the second option we have given nc4 plus nc2, and the third option we have given nc4 plus nc2 plus nc2, right? And the last option we have given nc4 plus nc2 plus nc1 times nc2, right? So we need to find that which option is correct, right? So everyone please try to solve this question, then we will discuss a solution, right? So in this you can break this 1 plus x square plus x cube in two terms, right? And then try to apply the binomial expansion in that two terms, right? And then try to find that what will be the coefficient of x ki power 4, right? Because you can break this term as 1 plus 1 plus x times, what you can write, you can write 1 plus x times 1 plus x square, you can write now. Yes, so try to apply the binomial expansion in these two terms, right? So what you will get, you will get this value equals to 1 plus x ki power n plus 1 plus x square ki power n, right? So try to apply the binomial expansion on these two term, and then try to find that what will the coefficient of x ki power 4. Yeah, so everyone please try to solve. Okay, anyone got the answer? Okay, let's x plus x square plus x cube की power n as 1 plus x times 1 plus x square की power n, right? So this will equals to 1 plus x की power n times 1 plus x square की power n, right? So when we will do the expansion of 1 plus x की power n, so what we will get, we will get 1 plus nc1 times x plus nc2 times x square plus nc3 times x cube plus nc4 times x की power 4 plus dot 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 plus ncn times x की power n, right? And if we will do the expansion of the second term, so what we will get, 1 plus nc1 times x square plus nc2 times x की power 4 plus dot 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 plus ncn times x की power 2n, right? So you just need to see the coefficient of x की power 4, right? So therefore the coefficient of x की power 4 we will get, that is nc2 plus nc2 times nc1 plus nc4, and this is equals to nc4 plus nc2 plus nc1 times nc2, right? So here we have found the coefficient of x की power 4, right? So now we are going to discuss the next question. So in this question we have given the middle terms of 1 plus 1 by x plus x sin x की power 10, and this is equals to, we have given 7 plus 7 by 8. So we need to find that what will be the value of x, right? So let's see the solution, how we can find the value of x. So the correct answer is c, right? So now we are going to see that how c will be true. So we have given 1 by x plus x sin x की power 10, and here n equals to 10, that is given, right? So we know that if we n equals to 10, n equals to even, so in that case the middle term is n by 2 plus 1 at term, and here n equals to 10, so that's why 10 by 2 plus 1 at term, that is 6 term, right? And we know that how to calculate the 6 term, because we know that the formula of t r plus 1 means the r plus 1 at term is ncr times x ki power n minus r times a ki power r, and here r equals to 5 because we want to calculate 6 term, so t6 equals to 10c5 times 1 by x ki power 10 minus 5 times x sin x ki power 5, right? So this will equals to 252 times sin x ki power 5, and this is we have given that 7 plus 7 by 8, and this will equals to 63 by 8, right? So when we will simplify this, so we will get this value as sin x ki power 5 equals to 1 by 32, right? So from here we will get the value of sin x equals to 1 by 2, right? So sin x equals to 1 by 2, it means that sin x equals to sin pi by 6, right? So we have sin x equals to sin pi by 6, so from here we can calculate the value of x, and this is equals to n pi plus minus 1 ki power n times pi by 6, right? So now we are going to discuss the next question. So in this question we have given that if the seventh term in the binomial expansion of 3 divided by cube root of 84 plus root 3 ln x ki power n, where x greater than 0 is equals to, we have given that the value is 729, right? So we need to find what will be the value of x, right? And we have given 4 option, then we need to find that which option is correct, right? So the correct answer is B, right? So now we are going to see the solution how B will be true, right? See that we have given the seventh term, right? And we know that how to calculate the seventh term, because we know that the formula of the r plus 1 at term means t r plus 1 equals to ncr times x ki power n minus r times a ki power r, right? And here we can take r equals to 6 because t 6 plus 1 equals to t7, right? So when we will calculate the value of t7, right, so what we will get nc6 x ki power n minus 6 and a ki power 6, right? And here we have the value of n equals to 9, right? So when we'll put this value, so finally we will get the value of t7 equals to 9c6 times 3 divided by cube root of 84 ki power 3 plus root 3 ln x ki power 6, and we have given that the seventh term is 729, so this will equals to 729, right? So after simplification we will get this value as 84 times 3 ki power 3 divided by 84 times 3 ki power 3 times ln x ki power 6 equals to 729, right? So from here we will get that the value of ln x ki power 6 equals to 1, right? So ln x ki power 6 equals to 1, so from here we can say that ln x equals to 1, right? So that's why the value of x equals to e, right? So here we have calculated the value of x and we have found that the value of x equals to e, right? So thank you for your attention. I hope this session was useful. Hello students, welcome to today's lesson. In today's lecture, we are going to learn about systems of particles and rotational motion. And this is theory part 1. Alright everyone. This is our disclaimer. So firstly, let's see trend analysis of the chapter system of particles and rotational motion in JEE main exam. So if we talk about the overall weightage uh, according to last 5 years, so we can say it is 5.4%. So this chapter is very important for the exam. And if we talk about the yearly question distribution, so we can say in 2024 question asked from moment of inertia, number of questions 1, and their difficulty level question was average. Similarly, if we talk about the in 2023 question asked from equilibrium of rigid bodies, number of questions 1, and their difficulty level average. In 2022 question asked from center of mass, radius of gyration, number of questions 1, and their difficulty level we can say question was easy. In 2021 question asked from moment of inertia, number of questions 1, and their difficulty level easy. Similarly, in 2020 question asked from angular momentum, and number of questions 1, and their difficulty level average. So from this analysis we can say moment of inertia, equilibrium of rigid bodies, center of mass, radius of gyration, angular momentum, these are the important topics for the JEE main exams. Alright everyone, we will learn each topic here. So are you ready for the today's lecture? So the topics which we will cover in today's lecture: first, center of mass. After that we will discuss center of mass of two particle system. Then we will learn center of mass of n particle system. Then Cartesian components of the center of mass. Then motion of center of mass. Then momentum conservation. Then rigid bodies. Then center of mass of some rigid bodies. Then we will discuss moment of inertia. After that, radius of gyration. Then theorems on moment of inertia. Then theorem of parallel axis. Then theorem of perpendicular axis. And last we will discuss about moment of inertia of some geometrical objects like triangle, circular, rectangle, square. Alright everyone. So first concept is center of mass. So think about it. So if we talk about the center of mass, we can say the center of mass of a system or body is a special point that represents the average position of all the mass in that system. It is like a balance point where you can imagine the entire mass of the object being concentrated. So look at here, we have a pen, alright. Or if we talk about the center of mass of this pen, so we can say the midpoint, alright. The midpoint is the here center of mass of this pen. Yes or no? So another example, if we talk about another example, so we can say balancing a ruler on your finger. So if you try to balance a ruler on your finger, there is a one special point along the ruler where you can place your finger so that the ruler balances perfectly without tipping over. So this point is center of mass of the ruler. At this point, weight of the ruler acts as if it is all concentrated there, and
the roller stays balanced because the torque around that point is 0. So in the pen, the point is midpoint. I think the concept of the center of mass is clear. Alright. The whole mass of the system, whole mass of the body to be concentrated at a specific point. Alright. Now we will discuss about center of mass of two particle system. Suppose we have a two particle in a system and their mass is m1 and m2. So each particle is located at a position in space described by position vector r1, alright, and r2. r1 and r2. So the center of mass of the system is the point where the combined mass of both particles can be considered to be concentrated. You know the formula to calculate the center of mass? So mathematically we can say RCM. This one RCM is equal to m1 r1 plus m2 r2 divided by m1 plus m2. Here m1 plus m2 is the whole mass of the system, total mass. This means that the center of mass lies somewhere along the line joining the two particles, closer to the particles with the larger mass. Alright, Varsa? Karthik? Clear? So this is the formula to calculate the center of mass. Now there is a special case. So suppose in the special case where both particles have equal mass. Equal mass means m1 is equal to m2, or we can say equal to m. So in that case, what will be the center of mass? So RCM equal to R1 plus R2 divided by 2. Alright. Now one question arises from this concept, and the question is, suppose if the masses of the two particle, listen carefully everyone, if the masses of the two particle is same, then uh, then listen carefully, then it is then the center of mass of the particles dependent on mass or independent of the mass. What will be the answer? Tell me. The question is, if the masses of the particle is same, suppose m1 equal to m2. Look at here in this diagram. All right. So here we have a two particles m1 and m2, and r1 and r2 are the position vectors from the origin O. So position vectors, and if the m1 equal to m2, it means the both masses of the both particles will be same. Then question is, the center of mass RCM is dependent on mass or not? Yes, tell me everyone. Yes, good. It is independent because look at here in this formula there is an absence of mass. RCM equal to R1 plus R2 divided by 2. So we can say if the masses of the particles is equal, then they are independent of masses. The center of mass is independent of mass. It depends on the positions of the particles. Alright. Now one more question. Suppose the m1 is greater than m2. In that case what will happen? And m2 is greater than m1. In that case what will be happen? Think about it. So suppose first let's see first condition. If m1 is greater than m2, alright, the center of mass, the RCM, this one is the center of mass. The center of mass RCM, this one will be closer to R1. Alright, will be closer to R1. In the second case, if m2 is greater than m1, m2, the mass of the second particle is greater than is greater than mass of the first particle. In that case, what will be the change in the center of mass? So we can say in that case it will be closer to R2. Alright, it will be closer to R2. this is valid only for if the masses are different. Alright, if the masses are same, then we can say it is independent of mass. RCM is independent of mass, because as you can see here, the formula RCM equal to R1 plus R2 divided by 2. Clear? Yes, right. Closer to heavier mass. Clear everyone? Good, very good. Now, center of mass of n particle system. Suppose we have a system, and in that system having more than 2-3 particles. Suppose first particle having mass m1, second particle having mass m2, third particle having mass m3. Suppose we have a n particles, n should be anything 1, 2, 3, 4 up to infinity. Alright, so we can say we have a n particles. In that case, their position vectors r1, r2 up to Rn respectively. Clear? Then how we can calculate the center of mass? The formula will be same, but the particles are in the system having in huge amount. So to simplicity, we will write the formula of the center of mass in terms of summation. Alright, so RCM equal to m1 r1 plus m2 r2 plus up to mn rn divided by m1 plus m2 plus up to mn. So in denominator, the m1 plus m2 and so on up to mn, this is the sum of total mass. We are denoted here capital M, and this one summation I to n. Look at here, summation I equal to 1 to n mi ri. So this one is the what? This is the product of mass and their position vector. Alright, this means the center of mass lies at the point where the entire mass of the system can be considered to be concentrated for the analyzing motion. Alright, this concept is fundamental in physics because it simplifies the study of the system's motion by allowing us to treat the whole system as if its mass is concentrated at single point. Alright, now we will learn about Cartesian components of the center of mass. So you know how we how we can write the position vector of a particle. So the position vector of the center of mass and the individual particles can be expressed in the terms of Cartesian components. Alright, so suppose we have a particle and we want to express their position in terms of along x-axis in terms of their Cartesian coordinates. Alright, x, y and z. So look at here, RCM is equal to xcm I cap plus ycm j cap plus zcm k cap. Xcm, ycm, zcm are the Cartesian coordinates of the center of mass along x, y and z axis respectively. And what about I cap, j cap, k cap? So we can say I cap, j cap, k cap are the unit vectors in those directions. Alright, similarly we can say in the terms of position vector in Ri, in the terms of Ri. So here Ri means I means ith particle. Alright, so we expressed as a Ri equal to xi cap plus yj cap plus z k cap. Xi, yi, zi are the Cartesian coordinates of the ith particle. Clear everyone? Varsha, VK, Karthik? Any doubt here? Alright. Now the Cartesian components of RCM are given by axiom equal to summation I equal to 1 to n mixi divided by capital M. Similarly, we can write ycm equal to summation I equal to 1 to n miyi divided by capital M, and zcm equal to summation I equal to 1 to n mizi. Now here mi is the total mass of the system. Alright, sorry, capital M is the total mass of the system. Clear? So these are the formulas for calculating the center of mass along their coordinates, along x-axis, along y-axis, and along z-axis. So these formulas mean that the center of mass coordinates are averages of the particles coordinates weighted by their masses, which determines the center of mass. All right, everyone. Now motion of center of mass. So the position vector RCM of the center of mass of n particle system is defined by RCM equal to m1 r1 plus m2 r2 plus m3 r3 plus up to mn rn divided by total mass, that is m1 plus m2 plus m3 plus up to mn. So uh, here in the term of in denominator, this is the total mass of the system, so that is capital M. So we will take common, so the remaining term is 1 divided by m into m1 r1 plus m2 r2 plus m3 r3 plus up to mn rn. So think about it, what is this one? So we can say this one is the m1, and r1 is what? R1 is dr1 upon dt. You know this one, r1 is dr1 upon dt. When we differentiate with respect to t in the above equation, when we differentiate with respect to t, so it will be r dcm divided by dt. So it will be equal to 1 by m1 dr1 upon dt plus m2 dr2 upon dt plus up to mn drn upon dt. This shows that the particle of the center of mass is the mass weighted average of the velocities of the individual particles. Now you know rate of change of position is velocity. So the differentiation of position with respect to time, it will be velocity. So we can write the above expression as a in terms of v. So vcm equal to 1 by m into m1 v1 plus m2 v2 plus up to mn vn. Clear? So this is the velocity of the center of mass. So we have a n particles, right? So this is very complicated to calculate their center velocity of center of mass. So we will use in terms of summation. So it will be vcm equal to summation I equal to 1 to n mi vi divided by capital M. Vi is equal to what? Dri upon dt is the velocity of the ith particle. This means the center of mass moves as if all the system's mass and the momentum were concentrated at a single point. These formulas are clear? If yes, please thumbs up in chat box. Similarly, we know the rate of change of velocity is the acceleration. So acceleration of center of mass ACM equal to summation I equal to 1 to n MIAI divided by capital M. Clear? Yes. Velocity, position, acceleration and position vector are clear? Please tell me in the chat box. VK, Varsha, mark your attendance. All right. So this is the acceleration. Now from Newton's second law of motion, the total force acting on a system of particles is equal to the total mass times the acceleration of the center of mass. So it will be m into ACM equal to F1 plus F2 plus up to Fn. So here, look at here, m is Cm. So this is the force and that is equal to F external, where capital M is the total mass, ACM is the acceleration of the center of mass, and F external, you know, is the resultant external force on the system. So this is just a representation in terms of center of mass of a complete system. Now for isolated system, if the external force on the body is 0, then F equal to m into ACM, which is equal to m into dv cm upon dt. This is the rate of change of velocity and you know rate of change of velocity is acceleration. So it will be what? It will be equal to 0. So VCM equal to constant. This means the velocity of the center of mass remains constant over time when no external forces act. Alright. Hence, the center of mass of an isolated system moves with uniform velocity along a straight line path and the momentum remains conserved. Yes, good evening, Karthik. Now, if some mass of area is removed from a rigid body, the position of the center of mass of the remaining portion is RCM equal to M1 R1 minus M2 R2 divided by M1 minus M2, or we can say RCM equal to A1 R1 minus A2 R2 divided by A1 minus A2. Alright, momentum conservation. This is very important. So basically, in momentum conservation, uh, the momentum of any system before we can say total momentum of any system remains conserved, or we can say remain constant. How? Let's see. So let us consider a system of particles with masses m1 m2 up to mn and their respective velocities v1 v2 up to vn. All right, so each particle has a linear momentum, yes or no? So their momentum, if we talk about the first particle, their momentum is p1, second particle p2, third particle p3. So we have a n particle, so the momentum, linear momentum of nth particle pn. So you know linear momentum is what? This is mass into velocity. So total momentum of individual particle is equal to p equal to m1 v1 plus m2 v2 up to mn vn. Alright. So we can say here the total linear momentum of the entire system is the vector sum of momenta of all individual particles. This means you add up the momentum vectors of each particles to get a overall momentum of the system. Mathematically we can say p equal to this. So if we talk about the velocity of the center of mass, so it will be VCM equal to 1 upon m m1 v1 plus m2 v2 plus up to mn vn. We already talk about this, where m is the total mass of the system. So just substitute the value of v, so it will be p equal to m into VCM. This equation p equal to m into VCM shows a very important relationship. Alright, so we can say the total momentum of the system is equivalent to the total mass multiplied by the velocity of center of mass. This simplification is often used in physics to analyze the motion of complex systems by focusing on their center of mass behavior. Clear? Karthik, Varsha, VK, and anyone? Our result. Clear? Any doubt? Okay, very good. Now, the total linear momentum of a system of particles can be expressed as the product of total mass of the system and the velocity of its center of mass. Alright. So, this is a fundamental result that connects momentum with the center of mass motion. So, now if we consider the rate of change of momentum with respect to time, So it will be dp upon dt is equal to m into dv upon dt. You know, rate of change of velocity is acceleration, so we can write dp upon dt, this one dp upon dt is equal to mass into acceleration, and you know mass into acceleration is what? That is force. So this expression, or we can say this equation, tells us that the time rate of change of total momentum of the system equals to the total external force applied to the system. It is essentially Newton's second law applied to the whole system through its center of mass. So if the external force acting on the system is 0, that is F external equal to 0, then the rate of change of momentum becomes 0. Okay, which means the total momentum P is constant over time. In other words, the total momentum of system does not change if there is a no external force acting on it. So if the external force of a system is 0, then the momentum of system of particles remains constant. This is a powerful and widely used principle in physics, which states that the total momentum of an isolated system, that is no external forces, is conserved. So if no outside force act on the system's total momentum before and after any instructions remains the same, and this is the momentum conservation. All right. Rigid bodies. So what is rigid bodies? A rigid bodies is defined as a body that does not experience any change in shape or volume when external forces are applied to it. All right. So we can say this means that no matter how the large the external forces might be, the distances between any two particles within the rigid body remains constant, never be changed. So this is the definition of the rigid body. In simply, we can say the shape and size of the body does not change if we applied any external force. So coordinates of the center of mass of the rigid body. So the center of mass represents a point where the total mass of the body can be considered to be concentrated for many physical analysis, specifically in mechanics. So here we have some expressions: xm equal to 1 upon m integration x dm, ycm equal to integration y dm, and zcm equal to 1 upon m z dm. These integrals calculate the average position of the mass distribution along each coordinate axis. Alright, effectively locating the point where the entire mass of the body can be considered to be concentrated. So you need to remember these formulas: xcm, ycm, or zcm. Alright. Now center of mass of some rigid bodies. So first, the center of mass of a uniform rod is located at its midpoint. Alright. So here, because of this uniformity, the center of mass, which is the average position of all mass in the rod, lies exactly halfway along the rod's length. If the length of the rod is capital L, then the center of mass is at a distance of capital L by 2 from the either end. This points acts as a balance point of the rod, meaning if you are support the rod exactly at this point, it will balance perfectly without tipping. Okay. Now think about it. This is the rectangular shape, this is the square, and this is circular. So this is uniform shapes. So what about what will be their center of mass? Just tell me. Yes. So here we can say for a rectangle or square, this is the point where the diagonals intersect. Diagonals intersect this point and this point. And for circular plate, it is the exact center of the circle. This means if you imagine cutting these plates at their centers, each half would have equal mass and balance perfectly at the center point. Alright. Now, the center of mass of a uniform semicircular ring lies at a distance of h is equal to 2r divided by pi from its center. So, look at here. From the center is this one and r is equal to here. This is the center of mass. The formula h is equal to 2r by pi comes from integrating the position of all small masses element along the curved length this, right, of the ring and averaging their positions weighted by mass. The result tells us a fur inside the ring of the mass. Alright. Now the center of mass of a uniform circular disc having radius capital R. So the semicircular disc is a flat two-dimensional shape with radius R. The mass is uniformly spread over its area. So because of symmetry, the center of mass lies along the axis of symmetry. So the distance h of the center of mass from the center O, this one, alright, this one. So we can say h is equal to 4r divided by 3 pi. This means the center of mass is positioned above the flat edge, closer to the curve path. Closer to the curve path, reflecting the distribution of mass. So you need to remember all these formula. All right. From this chapter, question asked directly formula based. And center of mass of a hemispherical cell of radius r. So the we can say a hemispherical cell is a three-dimensional shape, alright, shaped like a half of a sphere with radius r. Its mass is uniformly distributed over the curved surface. The center of mass lie on the axis of symmetry at distance h. So from the center O, the hemisphere h is equal to r by 2. So this shows the center of mass is halfway between the flat base and the curved surface along the axis of symmetry. And the center of mass of a solid hemisphere of radius r, here h is equal to 3r by 8. This value is less than that of the cell because the solid mass is concentrated more towards the base. Alright, clear everyone? Now we will learn about moment of inertia. So basically moment of inertia of a rotating body is its property to oppose any change in its state of rotation, state of uniform rotation. This means that when a body is rotating, it tends to keep rotating at the same rate unless an external torque acts on it. Alright. So, or we can say the moment of inertia measures how much the body resists change in its rotational motion. So, the formula to calculate the moment of inertia I equal to for n particle system. So, we can say I equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus up to mn. So, when we add all these terms, you will get summation mr square. Here, each particle's moment of inertia contribution is its mass multiplied by the square of its distance from the rotation axis. So the total moment of inertia is the sum of these contributions. Alright. For a rigid body having continuous mass distribution, I equal to integration dm r square. Uh, SI unit of moment of inertia is kilogram meter square, and it is neither a scalar not a vector. So that is, it is a tensor which generalizes these concepts to describe more complex directional properties. Radius of gyration. So if we talk about the radius of gyration, so we can say radius of gyration of a given body about uh, a given axis of rotation is the normal distance of a point from the axis, where if the whole mass of the body is placed, then its moment of inertia will be exactly same as it has with its actual distribution of mass. This means that instead of having the mass spread out in the body, you can imagine concentrating all the mass at a single point located at a distance called radius of gyration from the axis of rotation. So here point uh, we can say P from the axis of rotation, and the distance is capital K, matches the actual moment of inertia of the body with its real mass distribution. So the formula to calculate the radius of gyration, K equal to under root I by m, or we can say K equal to r1 square plus r2 square plus r3 square up to rn square divided by n and whole power 1 by 2. So SI unit of radius of gyration is meter, and radius here k changes, k changes if you can change the axis around which the body rotates, or if the shape, size or mass distribution of the body changes. It is not a fixed property of the object alone, but depends on how and where it is you measure it. All right. Theorems of moment of inertia. There are two theorem. First, theorem of parallel axis. Second, theorem of perpendicular axis. All right. So first we will discuss theorem of parallel axis. This is very important. So here to find the moment of inertia about any axis, you first find the moment of inertia about the axis through the center of mass, which is often easier to calculate or already known. Then adjust the result by adding md square, which accounts for shifting the axis by distance d. So look at here in this figure. The figure illustrates a body with two parallel axes, first one and second one. All right. Or let's see, axis A. All right. This one axis A, axis A, and this is axis CM. This one axis CM. So axis A is the axis about which we want to find the moment of inertia. Clear? And axis CM, this one, passes through the center of mass of the body and is parallel to axis A. So the distance between these two axes is labeled d. So according to theorem of moment of inertia about axis A is the sum of the moment of inertia about the CM axis plus md square. This means moving axis away from the center of mass increases. So moment of inertia by md square. From this theorem, you will be we can say you will be uh, able to find out the moment of inertia of any irregular shape. So if you know the moment of inertia about this line, so you are able to find out the moment of inertia along this axis by this formula, I equal to ICM plus md square. All right, clear? Yes or no? Next theorem we have perpendicular axis. So look at here the figure. The figure shows a planar body lamina lying in xy plane. The x and y axis lie in the plane of the body intersecting at point O. Alright. The points M, N, and P in xy plane represent locations of the lamina. So according to theorem, the moment of inertia about z-axis passing through O is equal to the sum of moment of inertia about x-axis, alright, and y-axis passing through O. Clear? So mathematically, Iz equal to Ix plus Iy. If Ix and Iy are the moment of inertia of the two body about two perpendicular axes in its own plane, and Iz is the moment of inertia about an axis passing through point O and perpendicular to the plane of the lamina, then this equation will be valid. Clear? So in theorem of perpendicular axis, the point of intersection of three axes x, y, and z may be any point on the plane. Now we will learn moment of inertia of some geometrical objects. For uniform ring mass m and radius r, the moment of inertia is I equal to mr square, and this is their axis of rotation. And about diameter, the moment of inertia is equal to 1 by 2 mr square. And for uniform circular disc mass m and radius r, moment of inertia equal to 1 by 2 mr square, and this is their axis of rotation, this one. Alright. And about a diameter, I equal to 1 by 4 mr square. Thin uniform rod of mass m, length L, the moment of inertia equal to 1 by 12 ml square, and this is the axis of rotation. Similarly, uniform solid cylinder of mass m, length I, radius r, the moment of inertia is 1 by 2 mr square. And about an axis passing through its center or perpendicular to its length, moment of inertia is m into L square by 12 plus r square by 4. For uniform solid sphere, uh, about its diameter, I equal to 2 by 5 mr square, and about its tangent, I equal to 7 by 5 mr square. Clear? Now let's see what this is summary for our lecture today. We know we already learned center of mass of two particle system. Then we learned center of mass of n particle system. Then Cartesian components of center of mass. Then motion of center of mass. Then momentum conservation. Yes or no? Then rigid bodies. Then center of mass of some rigid bodies. Then moment of inertia. Then radius of gyration. Theorems of moment of inertia. Then theorems of parallel axes. Then theorem of perpendicular axis. Then moment of inertia of some geometrical objects. Alright. Thank you for your attention. Now students, we will solve some practice questions based on these topics. So are you ready for the practice question? Yes or no? Tell me. Students, now we will solve some practice questions based on system of particles and rotational motion. This is our disclaimer. So here we will solve some practice questions based on system of particles and rotational motion. So question first, a body A of mass m while falling vertically downwards under gravity breaks into two parts, a body B of mass 1 by 3m and a body C of mass 2 by 3m. The center of mass of bodies B can and C taken together shifts compared to that of body A towards. Given options, option A depends on height of breaking, option B does not shift, option C body C, and option D body B. So here you have to find out the there is a shift uh, in there is a shift in center of mass, or we can say yes, is there a shift in center of mass? Think about it. If yes, also on which side? Think everyone. Please solve this question. VK versa Karthik. This is a very easy question, concept based question. All right, and tell me the answer. You have some time. After that, we will solve this question. Varsha, Karthik, which one is correct? Karthik, anyone? Yes, which one is correct? Let's see the answer. So correct option is option B. Yes, your answer is correct. Varsha, VK, good, very good. Let's see the solution. So here a body A, suppose having mass capital M, uh, is falling vertically downward. Okay, so due to gravity, while falling it breaks into two parts. Body B with mass 1 by 3 and body C with mass 2 by 3. Alright, so the center of mass of a system of particles is the weighted average of their positions, weighted by their masses. So when the original body A, suppose having mass capital M, breaks into two parts, uh, having mass 1 by 3 and 2 by 3, the forces causing this break are internal forces within the body. Okay, internal forces act between parts of the body and do not affect the overall motion. This is very important concept. Internal forces do not affect the overall motion or the position of the center of mass of the entire system. Because of this, the center of mass of the combined system of B and C having mass 1 by 3 and 2 by 3 remains at the same position as that of the original body A having mass M capital. In other words, the position of the center of mass does not shift due to the braking. This is why the answer to the question is that the center of mass remains unaffected. Clear everyone? Concept, I think the concept is clear. Yes? Clear? Yes or no? Next question. Uh, Distance of the center of mass of a solid uniform cone from its vertex is z0. If the radius of its base is capital R and its height is h, then z0 is equal to what? Given options: option A, h square by 4r; option B, 3h by 4; option C, 5h by 8; and option D, 3h square by 8r. So which option is correct? Please try to solve this question. After that we will solve this question. Yes, tell me which option is correct. Yes, please solve this question. Okay, good. Uh, the name is Tarung. Good. Anyone? Good, Tarung. Good. Anyone? Please try to solve. Swatika. Good, very good. Swatika Vande. Anyone? Yes, yes, please try to solve. Yeah, good. Anyone? Okay. So correct option is B. So here we can say the cone has a base radius capital R and height small h, and we denote the distance from the vertex to the center of mass as z naught, as shown in the figure. All right. So first, here we you need to recall important fact, that is The center of mass of a uniform solid cone lies along the axis of symmetry. Okay, so at a height of h by 4 measured from the base of the cone. So since the height of the cone is small h and the center of mass is h by 4 above the base, to find the distance from the vertex which is at the top, so we measure down from the vertex. So the vertex is at the top, so the distance from vertex to the center of mass is z naught. So the relation will be h minus z naught equal to h by 4. This means the center of mass is h by 4 below the base, or eventually z naught distance from the vertex. So rearranging the above equation, you will be get z naught is equal to h minus h by 4. So solving this expression, you will be get 3h by 4. Therefore, the center of mass of the solid uniform is located at a distance 3h by 4 from the vertex along the axis. Good, Swatika. Tarang, good. Your VK, your option is correct. A circular disc of radius capital R is removed from a bigger circular disc of radius 2r such that the circumference of the disc coincide. The center of mass of the new disc is alpha r from the center of the bigger disc. The value of alpha is what? So here you have to find out the value of alpha. Given options: option A 1 by 3, option B 1 by 2, option C 1 by 6, and option D 1 by 4. So please try to solve this question. Which option is correct? Yes. Tarang, Swatika, VK, Karthik, Daksha. So correct option is option A. Let's see the solution. So according to question, a smaller circular disc of radius r is removed from the edge of a larger circular disc having radius 2r such that the circumference of the smaller disc coincides exactly with the circumference of the larger disc. We want to find the distance of the center of mass of the new disc from the center of bigger disc. The distance is given as alpha r, and we need to determine the value of alpha. Alright. So let the mass of the original larger disc be m. Since the disc is uniform, so its mass proportional to its area. So area of larger disc will be what? 4 pi r square. So the smaller disc removed has radius r. So that its area is pi r square. So the mass of the smaller removed disc is proportional to its area. So it is m divided by 2 r whole square into pi r square. So it will be m by 4. So the remaining disc has mass m minus m by 4 equal to 3 m by 4. Alright. So let's place the coordinate system such as the center of mass of larger disk as the origin O2. The center of smaller removed disk is at O1, which is a radius r away from O2 along the line joining their centers. So to find the center of mass of the remaining disk, we will use the principle of moments. So taking the moments about the center of larger disk O2, so we can say mass of remaining disk into minus alpha r plus mass of removed disk into r, which is equal to 0. So it will be minus 3m divided by 4 alpha r plus m by 4 into r equal to 0. So when we solving this, you will be get alpha equal to 1 by 3. So the correct option is what? A. Alright. Tarang, your answer is correct. Very good. W- w- Very good. Alright. Next, consider a two particles system with particles having masses m1 and m2. If the first particle is pushed towards the center of mass through a distance d, by what distance should the second particle be moved? So as to keep the center of mass at the same position, given options: option A m2d divided by m1, option B m1d divided by m1 plus m2, option C minus m1d divided by m2, and option D. So which option is correct? Please try to solve this question. After that, we will provide the solution. Yes, please solve. So correct option is option C. Let's see the solution. So according to question here, we will consider a system of two particles with masses m1 and m2 as shown in the figure. First particle is pushed towards the center of mass by a distance d. The question asks by what uh, distance should the second particle be moved, so the so that the center of mass remains at the same position. So to keep the center of mass fixed, the velocity of center of mass must be 0 during these displacements. This means the total momentum change of the system is 0. So that is m1 v1 plus m2 v2 divided by m1 plus m2 equal to 0. Here v1 and v2 are the velocities of particle first and second respectively. So we can write it will be like m1 dr1 upon dt plus m2 dr2 upon dt equal to 0. Solving this, you will be get m1 dr1 plus m2 dr2 equal to 0. So dr1 dr2 represents the change in displacement of particles. Alright. So let second particle has been displaced by x. All right. So we want to find the distance x by which the second particle should be moved. So m1d plus m2x equal to 0. When we solving for x, so x will be minus m1d divided by m2. Here negative sign indicates the second particle should be moved in the opposite direction to the first particle's displacement to keep the center of mass fixed. Therefore, if the first particle is pushed towards the center of mass by distance d, the second particle must be moved away from the center of mass by a distance m1 d divided by 2 to maintain the center of mass position unchanged. Okay, so C option is correct. Alright everyone. Next one. Uh, a wheel has mass of rim 1 kilogram having 50 spokes, each of mass 5 gram. The radius of wheel is 40 centimeter. The moment of inertia is what? Given option. Option A 0.273 kilogram meter square. Option B 1.73 kilogram meter square. Option C 0.173 kilogram meter square, and option D 2.73 kilogram meter square. So which option is correct? Think about it. Yes, please solve. Yes, anyone? So correct option is C. Let's see the solution. Listen carefully. A wheel consists of a rim and 50 spokes. So the rim has a mass of 1 kilogram and each spoke has a mass 5 gram, which is 5 into 10 raised to the power minus 3 kilogram. Alright. So the radius of the wheel is 40 centimeter, which is 0.4 meter. We need to find the total moment of inertia of the wheel about its central axis. So the moment of inertia of the wheel is the sum of the moment of inertia of the rim and spokes. The rim can be modeled as a thin ring. So the moment of inertia of a ring about its central axis is mr square. Alright. And similarly we can find the moment of inertia of rod about an axis through the end perpendicular to its length, that is 1 by 3 ml square. So just put add both mr square plus 50 ml square divided by 3. So when put the value of r and l and m, so you and solve this, you will be get I equal to 0.173 kilogram meter square. Clear everyone? Next one is the surface density of a circular disc of radius a depends on the distance as rho of r equal to a plus b of r br. The moment of inertia about the line perpendicular to plane of the disc is what? Given option. Option A pi a raised to the power 4 into a by 2 plus 2a b divided by 5. Option B pi a raised to the power 4 into a by 2 plus 2b divided by 5. Option C 2 pi a cube into a by 2 plus ba divided by 5. And option D none of these. So which option is correct? Think about it. Yes, which option is correct? Let's try to solve this question. So correct option is A. So here we are given a circular disk of radius A, whose surface density varies with distance r, and from the center, so rho of r equal to A plus br. Okay. So consider an infinitesimal ring element of disk at radius r with thickness dr. The area of ring is dA equal to 2 pi r dr. So to mass of the ring element, dm is the product of its area and surface density. So dm is equal to 2 pi r dr rho, which is rho is A plus br into 2 pi r dr. Okay, so when we integrate 0 to A dm r square, so it will be, after putting the value of dm and r, you will be get A into pi a raised to the power 4 divided by 2 plus 2 pi b into a raised to the power 5 divided by 5. So when we solving this, you will be get A into a raised to the power 4 into pi a by 2 plus 2ab divided by 5. So this is our correct answer. Alright, one last question, and this is homework for you. Question is, 4-point masses each of value m are placed at the corners of the square ABCD of side L. The moment of inertia of this system about an axis passing through A and parallel to BD is what? Given options: 2 ml square, root 3 ml square, 3 ml square, and ml square. Think about it. This is homework. Okay? Yes or no? So correct option is C. So 4-point masses each of mass m are placed at the corners of square ABCD with side L. So we want to find the moment of inertia of this system about an axis passing through the point A and parallel to the diagonal BD. So the moment of inertia about an axis calculated by summing of contributions from the three masses other than one at A itself. So since mass at A lies on the axis and contributes 0, so moment of inertia is uh, I x prime equal to m into dp square plus m into bq square plus m into c square. So just put the value of dp square, bq square and c square and solve it. You will be get 3 ml square. Clear everyone? Okay. So that's all for the today's lecture. Thank you for your attention. Thank you. Thank you for your attention, everyone. Any doubt? If you have any doubt, please ask. No doubt? Thank you.